Check, check, check. 1, 2, 2, 2. Check, check, checking. Cool. Yep.
All right, we are recording. We are rocking and rolling. Thank you so much, Phil. And I will hand back off to you to be able to get us started because I think we've got about 20 people on the line. And we'll just kind of hold this room open all day. So
Cool. Yeah, I don't know if we're waiting for anyone else locally. Not that we're going to wait and not move forward, but I think we had 10 register in person and we're 6 of us. So yeah, we're close. So yeah, I think a couple points of order. VBAT's just posted the HackMD agenda in Slack. I think although the Zoom chat is there, we were thinking it'd make more sense to use Slack because there's more permanence there for chatting throughout the day. It won't disappear when we leave. Sorry, I'm figuring out where my browser window went. So yeah, there are a couple breaks in the day, and then there's a 90-minute lunch break. So those of us in the room will kind of disappear because here at the conference site, we can't have food or drink in this room. So we'll have to leave so we can not fall over with dehydration or anything. And yeah, so, I think it's a fairly full day as far as, the agenda filling out our 9 to 5 time, except for that last half hour. So I don't know if there's a way to fit in things that aren't on the schedule, but I think we'll just take it as it goes throughout the day and see what we can accomplish. What else? Any other points of order that we need to figure out? This setup is, I don't know what it looks like on your end, but for us, it's pretty nice. We can see kind of the gallery view on a large screen to our right, and then we can pin, if people are sharing, we have another screen where we can have the presentation. Your audio comes through the whole room. So hopefully if you're not here, you'll have plenty of chance to be involved in the discussion. Oh yeah, Steve's trying to give you a view of what we see if you look at his video on Zoom. So I don't think there'll be a two-level discussion here in the room versus not in the room. So, but if anyone feels like we're missing your hand raise or attempt to speak, hop in Slack. We'll try and all be aware and watching. But yeah, I think that's kind of all the points of order. Is there anything we didn't get on the schedule that people expected? I know we listed a lot of potential topics, but again, I think given the schedule flow, I think we're basically full. But if it turns out there's an empty spot or something that needs to be shuffled, like let's we're not like 100 people. Let's make it useful for the people that showed up. So yeah, and we're 15 minutes early unless someone wants me to give a big rah-rah speech about OCI. But that gives us an extra 15 minutes if I stop talking now.
What is open discussion? I think that was part of.
Yeah, grab your mic. They're just on. They're fixed on.
Oh, okay. So I think it's just, open discussion. I mean, we try to make it as flexible as possible. There's literally, if somebody had something, put it on the agenda, and if there was interest, vote on it was the only thing. So we took a couple of them that we knew people were interested in and didn't hear from others. So if anybody, we got 15 minutes for open discussion, I guess, if people want to start there.
Sure. That's a huge coffee mug, Mike. That's nice. It's like 3 feet tall on the screen, so.
French press with cocoa and sugar.
Wow, nice.
I need at least 4 cups in the morning to get going.
But it's also like 10 o'clock for you. Or 11.
No, it's 11.
It's 11:15. Yeah, but I've been on calls for hours. So
True. Living in one time zone does not prohibit other time zones from communicating. Yeah.
Yep. Yeah, Asia Pacific is extremely excited about confidential computing, apparently. So it's keeping me busy. I guess one of the things we can cover, or I wasn't really able to get any of the runtime, engine folks involved in this. Sorry about that. But I think one thing that's important to recognize is that they are starting on a quarterly release cycle. So I'm sure maybe not everybody is aware of that. And if you've got some fixes or changes that you need to see in Run C, you got to get it in that cycle now. Similarly to how we do Kubernetes today.
Great.
I'm wondering if for each of the sections, do we want to keep something in HackMD for the action takeaway? So
Yeah.
like versus just
definitely.
talking about it, for an hour and then moving on. Like was kind of hoping that today would be a way for us to find
Yeah.
direction for certain things.
Did we get, I know Sargon set up one specifically for his. Did we set up one, or do we just want to use the normal OCI weekly one and you can yank it and put it in OCI afterwards? Like an OCI repo later?
Yeah, in fact, maybe it's just since we all have the today's agenda open, let's just add a notes section there, because I mean it's all markdown, so it's easy to move around later if we need to. So
Is there a template in there for today? Yeah, I'll put let me copy paste the template in there for the bottom.
sure, yeah. So
we'll have 8 people doing it at the same time.
yeah, but maybe it'd be good for someone to kind of sign up for that on each one and be a different person, so someone's not a permanent note taker. So yeah, that's a great idea. So some notes and actions for each of those. And if there's going to be, Jason, I don't know if you have like presentation, but we can just use screen share on Zoom, and we're able to pin it on one of our screens so we can see it in here, and then everyone obviously who's on Zoom should see it. And then if it's shareable, like add a link to it in the HackMD.
All right, the template's there.
Cool.
I'm also happy to start early if we have nothing to fill the time until 12:30 or whatever time it is there.
Yeah, absolutely. I think,
Okay. Let me do that.
yeah, if there's nothing else to chat about, let's definitely get started. Who wants to do notes on Jason's? Anybody local or remote?
Also, if somebody could let me know if they see that, that would be helpful.
Yeah, yep, we've
Okay.
got it here. Yep.
Cool, cool.
Visible remotely.
All right. All right, I guess I'll start.
Yep.
Whoever wants to take notes or action items or whatever can do so. The session, this is mainly a discussion session. I made a few slides to just sort of level set and get everybody on the same page and to pontificate for a little bit, but the intention is to have a discussion about all of this and not to just watch my slides. So I'll get through these as fast as possible. Who's this guy? I'm Jason H. I'm literally at I'm Jason H basically everywhere, Twitter, GitHub, everything. I live in Brooklyn. Come and say hi. We'll have a pizza. I work at Red Hat on developer tools. I was formerly at Google on Google Cloud Build and Google Code. And to give you an idea how long I've been at Google, I was on Google Reader for a while. At Google and now at Red Hat, I worked on Tecton and OpenShift pipelines and Shipwright and various other tools to build and do stuff with containers. And I'm on the Continuous Delivery Foundation governing board and TOC. I'm a relative OCI noob. I've mainly got years of experience using and abusing containers from the outside and not a lot of experience making changes to them on the inside, but I'm excited to join the new kids, the cool kids table and see what we can do to these various foundational specs. Again, you probably won't need this. This is a quick history lesson about image spec. Image spec, as we all know, defines how to describe a container image, a runnable thing, and an image index, which is a group of runnable things, and a layout format for expressing those things on disk. These are JSON documents with content addressable pointers to other things, giving you Merkle DAGs, which is like a superpower in computers. Image spec is not alone in the world. Runtime spec depends on image spec. Distribution spec runs on image or depends on image spec, and so it's sort of at the core of this three-way Mexican standoff or N-way if there are other things that depend on these things. Distribution spec moves around images as described by image spec, and runtime spec knows what to do with them when you have them. It knows how to make practical use of an image by running it. And that has all basically worked. Client and registry implementations have blossomed. An entire ecosystem and industry has built up around containers using these APIs. All of us here represent many competing vendors working together for the benefit of our users, and we are all, I assume, gainfully employed. Nice work, everyone. Thumbs up. Everything's fine. And so in July 2017, image spec v1.0, and then a minor edits in November of that year, and everything has been pretty good. But since releasing 4+ years ago, not a lot of movement has happened to image spec, especially recently. Some minor clarifications and improvements from about April to about August. I got an annotation approved, or 2 annotations. That was pretty cool. For some reason, all changes to image spec happen on a Monday. I did not realize this. What is it about Mondays that makes people want to update image spec? And some people would say this is working as intended, right? This isn't intended to be any sort of disparagement to the spec or to the group here that's working on it. Nobody wants a platform that's constantly shifting and breaking. Nobody wants something that changes and makes 1,000 breaking changes a month. And that's why we have this group in the first place, is to make sure that we make slow, steady changes responsibly. But it can also kind of look like this, or for a little tamer example, also from Frozen 2. Fun story, I took this screenshot on a YouTube clip, and my daughter in the other room heard Frozen was on and was like, oh, I want to watch Frozen. So then we had to watch Frozen. And it can also look like this, like Tron, who fights for the users. Like I said, users just want stability over all else. They just want to build and run their software and engage in commerce and want us to get out of the way and not break their things. Lack of change can entirely be working as intended. But stability is one feature of many competing features, including speed and security and cost and compatibility. And as in all software, you they all interact with each other. To make something faster means a little less stable, or to make it more secure means it's a little more costly, and you can't have all of them at once. But reports of image spec being frozen are greatly exaggerated. This is a comment on the issue, is image spec frozen? And basically, I don't think this is like authoritative, but I like the way it was said. Backward compatible changes can be made without changing the major version number. And we want to avoid bumping the major version number as much as possible to avoid Python 2.3 madness. And in fact, the image spec is designed for extensibility. In the spec, it says implementations that are reading or processing manifests must not generate an error if they encounter an unknown property. So this is the superpower that gives the spec the ability to add new fields without breaking compliant implementations. In practice, it turns out sometimes that's not always the case, but ideally, and I think we can gloss over the cases where it's not, ideally we can add new fields. We have the ability to add new fields without breaking compliant registries. Here's a set of kinds of changes we could make if we were interested in them. I want to talk more about all of these and specific examples of them, but we can add new annotations. We did it recently, reserved predefined annotations. We can accept new media types. The OCI v2 doc and this afternoon's talk about other file system representations specifically goes into that for how best to more efficiently and quickly and cheaply represent file system representations better than tar. But in practice, these would require client or runtime support to actually benefit from it. If images can talk about some new exotic file system format, but the runtime can't make sense of it to run it, and distribution, well, distribution shouldn't really care, but if distribution did care, then it would need to update to that. We can define new fields, like I said before. See the extensibility section before. These would also might require some client and runtime support to actually benefit from them. If we added the data field that has been proposed to the spec for images, then this has potential downstream effects on distribution and runtime. See before the three-way standoff of things all depending on each other. And we can relax musts in the spec into shoulds or mays. These should be safe changes to make. You can make formerly required fields into optional. You can have other things that aren't layers. You could have other things that aren't config. You can do this, but runtime spec may still depend on some of these fields. If you got rid of it, if you had an image without layers, that image spec considered valid, and runtime spec, what would a runtime do with that if it didn't have layers? And in theory, again, distribution spec shouldn't care, but in practice probably does. In any talk about a V next, we have to talk about compatibility, and that's an important topic because fundamentally users just want to not be broken by our changes. We are Tron fighting for our users, and this whole group is about compatibility. That's why we have these specs, to be able to have compliant implementations of all the specs. And there's a conformance test suite that ensures implementations satisfy the spec, and conformance tests are always incomplete, but I think good to have, or excellent to have, and in a good shape, in particular for OCI. In particular, there's a case where if you relax a must into a may, a registry that, a compliant registry that had expected it to be a must might not assume it can be a may, and so might give you a validation error and say, oh, but you need to have a config, you need to have a layers. And so registries won't adopt this relaxation on day one and may never adopt it. So that's a practical compatibility question that I think we have to wrestle with. Yeah. My proposal is that we think about everything in terms of a v1.1, not a v2, as mentioned before in that doc, or in that comment about v2 can be a lot hairier, and it has the problem of the Python 2 to 3 migration dumpster fire. But a 1.1 can signal, yes, there are changes, and implementations might need to change to support v1.1, but v1.0 will still always exist. This also, I think it would be useful to, my overarching goal in all of this is for us to think about a 1.1 so that 1.2 is easier to think about, so that 1.3 is easier to think about. So we exercise this muscle and get in a better habit about being able to make any change, whether that's for speed or cost or efficiency, or God forbid, if there's some sort of bug, we have to like do a release to fix that bug, then we would be happy to have exercised the versioning muscle more recently. Conformance is going to play a big part in this. We need a conformance suite that enforces the 1.1 rules if we have a 1.1, and which means a separate suite. You would need to be able to say this implementation is 1.0 compliant and 1.1 compliant, or only 1.0 compliant. I think we want to make 1.0 the standard, and like the gold standard, and say there are no changes to 1.1 that would make you non 1.0 compliant. That's sort of a third rail that we should avoid. In that case, you're effectively going to a V2 where you say, in order to be 1.x compliant, you would not be 1.0 compliant. That's something we should avoid. But I'm happy to talk more about that in more detail. Considerations around this, as before, all of these specs have interdependencies on each other. If image spec goes 1.1, would distribution spec need to have a 1.1 to talk about image spec 1.1 manifests? Would runtime spec have to have a 1.x to talk about being able to run image spec 1.1 things? Would they need to release in lockstep? What is the order of their releases if they're not lockstep? I don't have answers for this. I only have questions, but I'm happy to talk more about people's concerns and thoughts on that. And as always, the practical concerns, we are humans with limited time and energy. Changes are made of people. Changes require people to push them through. And so therefore, changes must demonstrate real value to end users to justify the work. It's not about just improving the spec for our own, love of a well-made API. It's really about, making the world better for users that just want us to get out of the way. And another practical consideration is that we need to have image spec maintainers that are, able to vote on changes and approve changes, whatever they are, or disapprove or reject changes with quorum. We'll talk, I think we have a big session later about OCI artifacts, but I wanted to mention it here. Artifacts, as I see it, artifacts effectively extend the image spec to describe anything. Where image spec describes runnable images, artifacts describe SBOM, signatures, Helm charts, OPA policies, shopping lists, baseball rosters, kind of anything. They are stored and served via the distribution spec. And as far as I know, there's no requirements that, changes to artifacts don't make any changes to runtime spec, because runtime doesn't assume artifacts are runnable. There's a lot of good, interesting work going on in ORS to add the references stuff that I think Steve will probably talk about a little bit later. This is really what we're doing, right? We're swapping out a great golden thing for, well, I don't want to describe v1.1 as a bag of sand, but we have to be careful to swap out the thing we have with something of equal or greater value without causing that huge boulder to come down. And so we really have to be careful. And yeah, I just want to have, I want to kick off a conversation about it. I saw this on the wall of my daughter's kindergarten class, and I thought it was like fantastic. And so I found it on the internet. But like, where are you on these steps? Are you at, I won't do it, I can't do it? Are you at, I can do it, I will do it? I think it's useful to me to think when I'm feeling like not doing something where I am on those steps. So with that framing, I'd love to open the floor to discussion and get people's thoughts on either what kinds of changes you would want to see, what kinds of changes you're not excited to see, what you're worried about as representation from distribution implementations or runtime implementations. Yeah, really the floor is open, and I look forward to discussing more. Does anybody have questions, comments, ideas?
Can you hear me? No.
Almost.
Here, Vincent.
A little more volume,
Oh,
just a little quiet.
the OS is messing with me. Hello,
There you
hello, 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 hello. Okay. No, yeah, thank you for that. Some of the relaxing musts to shoulds, I think that was always something we kind of tap danced around of like whether to even make something a must or how many things can be shoulds or may or whatever is possible in the first place. Because something like that does feel often breaking or like it just won't ever make its way out, like you said.
Well, it's way
Um,
easier to relax. It's easier to never have to relax them, right? I remember in some of the discussions around even that the base image annotations, it was like, do we want to be prescriptive and require things about the value of this annotation, or do we want to say, you know, we expect it to be this, it should be this, but if you put in your social security number, we can't really stop you. So yeah, I think that shows up, the hesitance to relax things shows up mainly in trying to be careful about relaxing as much as you can when you define a new thing. But I agree, we've never, as far as I know, there has never been a change or a strong proposal to relax a must into a should or a may because of exactly the kind of consideration. But I think once if we sort of open the door to a 1.1, we can reassess that.
I think many of us, it's kind of this is funny logic, but I kind of wish Trevor King was here so that he could pull out the history decks of all the references. But there was a few conversations that we had about this in the past, even as we were approaching a 1.0, of like whether SimVer was even the right approach, because pretty much it effectively wasn't, you know, for a spec, that it should just be largely a constant refinement. Like if we have something, call it a V1, not 1.0.0, but like a V1, that's like the moving target. And that everything after that should likely be something like a feature flag, you know, and possibly even break down a lot of these different fields of like, do you even support this particular vocabulary or otherwise, or enhancement or whatever? Because even to go, like you said, to like a V1.0, even if for itself it can have its own versioning or life cycle, the kind of like implementations that clients do or registries do would end up saying, you know, like I'm supporting, you know, we branch to V1.1 and we add 2 features, and some clients support one of those 2 features but not the other, you know, and they like say, oh, that's an optimization we liked, but we're not going to implement the other one. So where are they? Are they like a V1.0 client with, you know, they'll sprinkle this other thing that they just happen to support? And it starts getting a little wishy-washy, and it became such a meta conversation that I think it exhausted people that were already ready just to be done with 1.0 and stamp it.
Yeah.
Were already like, I can't grapple with that thought just now, and we deferred the conversation. Because there are times when you might want to make certain optimizations that affect something you'd kind of group into V1.1, but may slide in other changes that don't get widely adopted or something, or inherited.
Yeah, I like the idea of, or the general concept of feature flags or optional feature suites, right? Where like if some client or registry or runtime doesn't support some feature, it can advertise that, or at least advertise it by breaking when you try to use it. And then the question becomes, what is the expected or required behavior of clients or runtimes that you know, now they can't push, you know, my new field or whatever. What are they supposed to do? Oh, there's some hands up. I'm sorry.
Oh, so I'm just gonna step back a little, and it looks like the people in the room have questions.
We should probably just do the raise hand thing as well, just get on level quote. So I think everybody here is on Zoom. I assume? Okay. Raise your, if you don't want to get on, just tell us, I'll raise your hand for you or something, and so we can do that. But why don't we, anybody objections?
Okay.
Nisha, why don't you go?
Okay. So I'd like to pick an example of what it takes to like make changes that may or may not be breaking. So for example, right now you can use annotations for a lot of the work that we would like to do, but it requires some amount of, I guess, hacking, because right now annotations only allow you to do like a, one key and one value at a top level. You can't really put any kind of structured data in the annotations. You can't organize, I suppose, pointers to other things that may be on the registry with annotations. We would like to do that. It's just going to be like a big old mess. So let me see how I can hack this. One key is one string, and the value corresponding to that key is a string, but actually you have to will probably do something in the back end that interprets it as a JSON blob of whatever the client tool understands. Okay, so that's not standard, but we would like to standardize it. Is there room in the spec to standardize something like this?
A clarifying question, to standardize the practice of putting JSON in annotation values?
No, I mean like actually making that JSON blob as a first-class citizen.
Right, sure. So I don't know if this is an acceptable answer to everyone. One silly hack you could do is that because you should be able to specify new unknown fields, you could make that a field in the resource, in the manifest, and say, I think for sanity, you could do org.nisha.something /name, and then you could stuff a JSON object in there, and registry should ignore it. But I don't know if that's an awful, awful sin according to people who are listening to me. Also,
well, so all of these are awful sins, right? Because they're not specified in the spec. So that's the problem. If the spec doesn't change, people will commit sins.
Well, it defines sin, right? The additional fields are supported. You're not supposed to throw an error, and the annotations can also be used. They're supposed to be supported, and they don't throw errors. It's really the process that you're looking for. If you want it, this to be a first-class field in a manifest that's supported by OCI in general, then we probably need a 0.1 or a new manifest type.
So the reason why we would want these to be a first-class citizen is so that the way that we, like the process is adopted by folks who are registry providers, folks who are using the runtime spec. I mean, that's why we do this. If you were to allow for someone who can say, well, this is like the bare minimum of what we would like something to do, I'm just going to say, oh yeah, this is OCI conformant, but we will layer things on top of it and make our own, make our own tools and ecosystem. And by the way, we will make our own fancy spec as well. Is that something you want to happen? Are you okay with that?
That brings up an interesting question, Phil, Vince. I think there's been a lot of consternation or difficulty around the around the concept of OCI waiting for, APIs to stabilize before we bring that API in, that spec in, that new manifest type in. But yet they're expecting us to be the experts and help them define that. So I think that, that OCI, we don't really want to be the front runner on these things. We don't want to lead and force. I think that seems to be coming up, quite often. I like Vince's idea of doing, extension features and optional testing type features to be a way to resolve that sort of thing. But I think that's where this is coming from.
Can I suggest like bubbling up just a little bit? Because I think Jason kind of had a core question of the types of changes. And I think if you can categorize those, then it makes it easier to understand when you could use which. Annotations is interesting and also complicated. Annotations is a thing that you can just add. I can just add the Steve annotation, and I probably need to ground it in some unique namespace of some sort, but that's just a known thing. There's no expectations for the registries to do anything with them. Today, most registries don't do anything with them, which I think is a catch-22 problem, that there isn't a standard feature that says, hey, you could index by these and find things by annotations and so forth, and we'd love to see that. But at the end of the day, even if we did support that, the complicated part, the only thing I would suggest there is we should probably put a size constraint on annotations. Otherwise, you can stick a 5 megabyte blob in there, and the thing's supposed to index it, and how are we creating, an index DB kind of thing. But my point is that there's this category of things that if we polished the experience around it to scope it, then yeah, you can just use annotations. And maybe Jason uses his annotation for a while until it's proved as everybody loves it. So let's promote it as an OCI standard. So that's just one category of things that can live completely in the image spec, as an example.
I think the only difficulty with that one is taking a page from the IETF with the X type headers on HTTP handlers, as that was originally intended to be a playground until they said, oh, this is a good header, let's promote it to first class. But by that time, everybody that was using it was already using the X type headers, so they just kept it. And it would never become an OCI. Like, we reserve the use of org open containers prefixes, but we want you to use them. And by the time you're using them, then you're not going to change it.
No, maybe I went a little bit too much detail, where that was enough to frame it as even what I thought was a simple thing could be complex. What I was going to just use as the counter to that, just to kind of frame them, is there's certain things we would like to put in the image spec that have an expectation from the runtime, or the most recent ones we've been talking about, the registry. It's not like it's a problem necessarily for Jason to stick a property. I'm sorry, I'm picking on Jason, Fred, whoever, to stick a property in. It's his session, so I guess I get to pick on him. So if Jason puts a JSON property, not just an annotation, but a property in one of these manifests, as long as he doesn't have some expectation everybody else is going to implement it because it's not part of a spec, then I agree, there's nothing wrong with it. The challenge is we're trying to do some of these things where there is an expectation that the registry would be able to do something with them, and not all of them, but some of them, and that we want it to be a standard. So I think all I'm suggesting is there's probably a categorization of things that we could change. It'd be really good to bucket them, because then I could say, look, I know I can change the car on my radio. Like, that's a thing I can do. Maybe not anymore, but I don't know. There's a certain bucket of things that people can do within a scope. But if your need is to have something across distribution and image spec, here's the method for that. And just trying to create some buckets that if we can work with.
Nate's had his hand up for a while. Nate, do you remember what you wanted to say?
For the most part, yeah. My major concern about having a feature flag is the complete mess that happened with OpenGL and IEEE floats, where it's just complete chaos as to what's implemented. I mean, I fully support having, experimental stuff, but I want some kind of baseline, which I like the SimVer for. If you're at version 1.3, you will have these features, period. Otherwise, you're non-compliant. And then have, whole test space. But I really don't want to get into some scenario where we're expected to do one or two things, or even a user expects one thing to work and it doesn't, or they're combining stuff like that. I want nice baselines and preferably some kind of way to test it. Thank you.
Yeah, I think it's also an interesting point about like I forget in what exact context, but there was a proposal to have a feature discovery API or something in distribution spec where you could say, hey, registry, do you support, feature X? And that always seems dicey to me because it's self-reported by the registry and their definition of whether they support some feature might mismatch your expectations. So I think like one way is to ask the registry or ask a registry what it supports, but you might not be able to trust it. Another way would be to try whatever the feature is, push the field, ask for this endpoint. And if it fails, then that means you have discovered it doesn't support the feature or it doesn't support the behavior you were expecting. I don't have specific experience with OpenGL and whether that was tried in that context and failed, or how the many ways it could fail. But it seems in general better to me to expect clients to discover feature compatibility rather than ask for it and get the registry's opinion about whether they support it. Curious what other people think, obviously.
Sorry, which way did you say you preferred?
I prefer, for example, the refers API is a good example. One possibility would, if I want to discover whether the registry supports the refers API, I could ask some endpoint that says, give me all the features you support, right? Like /features would give me a JSON list of feature strings or something. Completely making this up off the top of my head. Don't take this as canon. And if it says, I support references, then I could say, okay, great. I will go hit the refers API because you told me that it works. But if the spec is ambiguous about what it means to support refers, the refers string feature flag, then I might think having that feature enabled means something that is not actually true when I go to that endpoint. Whereas if I go to that endpoint and say, I want to get all references that match this filter because I actually want the filter feature of references, and it says, I don't know about features, or 400 features is not, feature is not enabled or something, then I've learned like canonically from the source that isn't supported, as opposed to referencing some list of supported features that may or may not be true based on my reading of those, and then going to the endpoint and saying, do you actually support it? Because now I'm actually asking for it. Does that clarify or just add word?
I think you're kind of bringing up, is there a bucket for this, for a capabilities API? And I worked on some of the phone platforms, and that works pretty well for phone devices. Obviously that's different, and I'm sure there's lots of failures on things and some successes. But I think without going into how do you design it, I agree. I think there is a question that I'd love to see some capabilities APIs that says a registry supports foo, and it's probably more than true and false. It might be, hey, I already support feature X in version 1. I support feature X with this capability. And
right.
And then hopefully, well, I'm going to design it. Hopefully the client can cache that information so that it doesn't have to ask it every time it makes an API request, but that's probably getting into details.
Right. My position is specifically that I don't want a capabilities API because it can be unreliable versus the ground truth of trying some endpoint and seeing if it succeeds or fails, or what kind of error it responds with.
Yeah.
I don't know if this is even on Nate's topic anymore, and Josh still has his hand up, so I'm also happy to drop it and come back to it later. Nate, is that helpful at all, or just sidetracking?
A little bit of sidetracking. I just want solid baselines, because those of us who are working on compatibility. I just want to be able to work towards it'll comply to this and everything else is optional.
Mhm.
I'm totally for having features that are optional, but it has to be able to work without them.
Yeah, I think in that case, the spec we have today is the baseline, right? Any new feature we add would be optional according to 1.0, and practically speaking would probably only be a should in 1.1. But I don't know. We probably need a specific example of something we want to add before we talk about specific example implementations. Josh, your hand has also been up forever.
Yeah, it's so related to like how do we know what the registry supports, or how do we know what's supported? I keep thinking about your slide with the Steve Carell and they're pointing guns, and like I'm curious what you think it means for image spec to be compliant. Is it how it plays with the registry and how it plays with the runtime? Can it be tested in isolation? The reason I say that is I'm wondering, like from a practical standpoint, is there a way that we could make the distribution conformance stuff a little bit more extensible, where right now, like there was a big effort to try to decouple distribution from image, but it's kind of like a joke because in the conformance we're pulling in the image spec Go libraries and forming an image and pushing blobs. I'm wondering if like there's something we can do with that code to make the way that you build an image or an artifact or something more pluggable, so that someone can come in with a new capability with like a JSON file or a YAML file and be like, this is the way this is supposed to look, or like a template or something, and run it against the same test to see if it works with the registry. And then if we could have something on the runtime side that is similar, then you could not wait on the spec to tell you this new feature. Be like, I have this file that defines a new feature. Whoever wants to play with it can run it against the conformance suite with this enabled. And then from like the organization side, like OCI can start to, put together some sort of matrix of these registries or these providers support these different like experimental or vNext features.
Yeah, actually, I noticed the issue you're talking about where the distribution conformance tests rely specifically on image clients and structs. I back when I was hacking on that thing to tell whether a registry supported the data field, I wanted to just make that a conformance test. I just want to say, like, not even like the data field specifically, but can I push a manifest that has XYZ as a field that you shouldn't know about, but you shouldn't fail if I push it to you. That problem was a specific problem in writing that conformance test, because all the conformance tests are phrased in terms of like, given a valid image object with these 5 known fields, what do I do? Well, you can't then test like, what do you do in presence of an unknown 6th field or something like that. So yeah, I definitely think there's an opportunity for improving the conformance test for that case, and which would start to weaken the dependency on image spec objects specifically. And then from there we can build on that to say, like, are registries conformant that accept this field or ignore this field that it should ignore. And then
feel like there's any way to test a new version of image spec in complete isolation? Like, does it mean anything to do that?
Is the question, is it possible to test like a conformance? Is there a conformance test suite possible for image spec in isolation that doesn't take into account?
Nothing to do with runtime or registry.
Right.
I'm trying to understand.
In theory it is, right? Like, but it would basically be, does this JSON document have a layers field? Does it have a config field? Does it have manifest version 2? it's not practically that useful to hold a JSON document describing an image if you can't move it or run it. Like, we're back to the three-way tango thing. But I think like what we're talking about is sort of making it useful to test an image in isolation, or making it extending the abilities of the conformance test suite to understand that unknown fields should be ignored. That's a weird sentence. So that we put up walls where we know there should be walls, so we can make progress on other features.
I had almost a different basic question. How would, if the distribution spec did go to 2, vNext, whatever, 1.1, how do you know? You can't even ask the registry necessarily what version it is, any more than you can look at an image spec, an image manifest to know, because the media type that says the version is not in the document. This was one of the ones that I was struggling with taking the media type out of the manifest definition. Was you can't look at the document and know what it is. Like
Right.
You have to guess at the schema, and if, picking on Jason again, if Jason happens to stick some properties in that we wind up putting in, I'm sorry, we'll call it 1.1. If we call it 2, I'm not trying to imply major or minor. I'm just trying to do it next.
Yeah.
If the image spec is 2 and we promoted Jason's property to it, how do we know that that's really 2 and this other property that should also be part of 2 is in it? So I think it's not just the capabilities API. I don't know, how do we know how the version is synced across the different specs as you interact with them?
Yeah. Brandon, did you raise your hand to answer that question, or?
Yeah, I'm
That's kind of
looking at that saying, I think you come at this from 2 different directions. One is from, if you're writing the client, you want to query the registry and see, does that interface give you a 404, or does it come back and actually give you a proper response? And I think you don't care about what version the registry is at that point. You just want to know, does your feature work, because you're trying to send a signature or something like that up to the registry and just need to know if the reference type is there. The flip side is from the users. And the users are looking at, I need a registry service in a cloud somewhere. And it would be nice if those different vendors out there said, we support registry 1.1, and then they just know, okay, it's going to support all these features. I don't have to go through and test each one of those or look through some long fact sheet about what the registry is. They just see it's 1.1, I can move on. OCI gave that stamp of approval and said it's going to have that. And the conformance test should just give them that stamp of approval. Conformance test should say you're conformant up to 1.x.
Yeah, good. That would have been my answer too. Does anybody have any more looming questions, concerns, problems with the general idea of a 1.1, or I don't know? It seems very scary to me, so I happily welcome any feedback on your concerns.
And I think it goes back to the questions, how do you know? It's like, we shouldn't just have to read docs, because even a 1.0 spec, we've argued in the conformance tests, what's required, what's optional, is push, pull, authenticate, discover. So it's really, you can't just say you're 1.0 compatible and you support X. And we'll use the favorite debated topic that we know it goes back and forth between image spec and distribution, is references API. It's not as simple to just stick a property in the image spec that you expect a registry to implement the ability to get the data back out. How do we communicate expectations back and forth? Should I have to ping the referrers API just to push a manifest that has a referrers property, but it didn't, but the registry is supposed to ignore that property if it doesn't know anything about it? But how do I know that if I'm pushing it, I can actually get the data back out?
Yeah,
Vincent, an example. I'm sure there's a dozen others that aren't so controversial, but that's the root of a lot of the conversations we're trying to have. What's the structure?
I think it's an excellent example change, right? It's an excellent example change of, yeah, sure, you can push a manifest with references today to any compliant registry. I haven't tried it, but I assume it'll work. But that's not really what you want to do with those. You want to be able to get the index and do the refers thing, right? So that's what you're talking about is not can a registry accept my references, but will a registry do something useful with them when I give them to them, right?
Right. And not just, can I get them back out, but is it going to get garbage collected in that fun conversation?
Yeah. Vincent, I think you were the next person with your hand up.
So a couple of, besides a couple of the actionable steps here, like having, I mean, we might even have a V1.1 milestone target or whatever, and like actually spinning the wheels of saying like, what would be in here? That's a fine actionable target. The two things that I hear shaking out of some of this, which is good, and I think but just to call them out specifically.
We lost the
It's
last.
kind of,
I'm losing you.
Vincent.
I think the things that the distribution spec relies upon that are defined in the image spec need to be teased out. Everybody just froze for me.
We hear blurted pieces from you, Vincent. And I'm assuming you're not just sitting there with your hands on your head still.
I can go next if anyone wants.
Yeah, we should come back to Vincent though, but
Okay. Yeah, we'll come back to Vincent once he's back. I actually didn't catch the reasoning behind why folks do not want like a capabilities or feature API. I would think that you could implement a core like must-have features, and that would address Nate's baseline needs.
I think I think I was the person who came out most strongly against the capabilities API. So I will try to answer this. Unless there is a conformance test suite holding you honest, like unless something says you advertise that you support the, for example, references API in your capabilities API requests, you said you support this, which means I'm going to run the battery of tests that prove that you do that, and that those results are public somewhere, and that my registry like links to my conformance test suite run that says that not only do I advertise that I support that, but I do actually support it. I think unless something is holding me honest, there's a lot of room for me to say that I fulfill this API, and not even like maliciously lying about it, but just like my read of the spec is inconsistent with someone else's read of the spec. And so I think that I support the references API, but I don't actually based on your expectations. So I think it all actually goes back to conformance. The capabilities API isn't necessarily something I don't like, but I don't like it in a vacuum without some conformance, something to keep me honest about it. Does that?
You want it more than user stars approve. Like if registry foo claims it supports some feature and it advertises it in their docs and it reports it on their capabilities API, one aspect is that registry gets a lot of upset users, and because it's not compliant with the spec. That's a cheap way to do it in one sense. We've seen the expense it takes to get conformance tests, although maybe having the baseline bed that you have, it's easy to add new conformance tests too. So I'm not objective to a conformance test. If you're going to write the code to implement some feature and add it to a capabilities API, which we haven't designed yet, let's assume we can get one, then filling in a conformance test doesn't seem like a high bar.
I'd just like to follow up on what I was saying earlier too. Like if you could run the suite and point to some directory with a custom image layout and somehow map that to what's being uploaded. And I put that in Slack too. I think it'd make it easier to test a new feature. Go ahead, Jason.
I forget what I was going to say, and that sounded good anyway. Vincent, are you back?
Maybe. Let's see. I'm now dialed in from 2 computers and I'm trying to figure out which one actually works.
That's promising.
Where was I in my thought? I'm sorry. Zoom is distracting me today. Actionable next steps. I think the things that I'm hearing are, if we could disentangle the pieces of distribution spec and image spec that are overlapped would be a huge thing. Because it's come up a few times, and I know for the sake of history, like the reason there's some stuff that was in image spec that should have been in distribution spec was just because the conversation was pushed so long and so far that it took us a long time to get to having distribution spec as a thing. Therefore, some stuff evolved in image spec that really should have been in distribution spec later, and it's messy. That needs to happen. The conversation about like opening a milestone for a v1.1, it might even be out there. It's fine, we can do that. Like the conversation I think is about ready for it, and obviously v1.0.z is calm and cool and collected and whatever, and if there's any departure from that, that's fine. But like you were talking about, of like relaxing musts and shoulds, or having a baseline of, you know, at least supporting this, but everything else is optional, or what would it mean even as the implications for a v1.1, to have some kind of rubric of like saying, hey, here's the thing that I'd like to see this in a v1.1, or, you know, even a v1.0, and saying, well, does it implement a new must? Does it, you know, like whatever kind of, like, what are the implications of it? And at least having a small stanza to say, cool, does it do these things? Does it, you know, do or not do this small rubric of things? Maybe rubric's not the right word, but still, to say, cool, this is not breaking. And ideally, yeah, it'd be even better if that was a conformance test. I feel like we tried and that got abandoned on just the image spec and kind of runtime spec. Like, if we can push for that, that'd be great. Build it into GitHub Actions, I don't care, like super. But at least being, you know, having enough of this discussion, and it's kind of circled around that obviously we're having a hard time finding the right words for it. But if saying this is or isn't breaking, or at least have a human eyeball and say, I think the implications of this are cool, that would really help, because right now some of those things are so subjective that it leads to lengthy discussion that I think exhausts a lot of people, and circles back to your other point of like, we're all like kind of like doing our best on this. And if a discussion gets circular or tiresome, consider it dead in the water. And anything that leads to conversation not getting circular or tiresome is the best. That was my point.
Totally agree.
I want to just angle in on the topic. What is the definition of versioning? What is the definition of what breaks and what's not? We've had endless debates just on that topic. So I think we have to go write that down so we can agree on that.
I agree. I think that would help it not be a circular death spiral conversation. Brandon, you also had your hand up.
Yeah, I was going to go back to one of the comments Steve made earlier of how do you detect some of these things, like the reference types. We'll keep using that as the common example we pick on. And this direction I'll go with that is that should be part of that extension, whatever they're doing for their spec, is they should include that in part of their definition of what they add for the API of how they can use this properly within their stuff, so they don't have to go out to some external system to check a version number or something like that. And so that's just direction I'll go, is just make that part of whatever you're adding. Is you need to be able to query it to see if you can use it.
How do you know that? Like, that is a good example of one that it's multiple pieces. regardless of what manifest spec it's in, let's just ignore that for the second. A client can submit up a document, a manifest, that says I'm pointing at something else. I'm referring to something else. I'm ignoring even the property. That's part one. Part two is I can get it out and it's indexed. There's some life cycle question, but probably the fact if you support those two things, the spec says that this is the behavior. But the problem is it's not as simple of, like, should I have to be able to say, does the manifest put get accepted? And if it does, well, if it's only a property, an additional property in the existing manifest, by definition, it will get accepted. Doesn't mean it's supporting it. So for every put, do I have to query the referrers API to see if it exists? I mean,
I think,
what I'm saying
I
is
think in
that some of these
advance,
properties
yeah.
are more complex.
I think in advance, if you're concerned about that, I think the answer is yes. You have to have something you can hit. Maybe it's refers API, maybe it's something that goes along with the refers API, but something you can query to know, is this going to be useful down the road? Or you can say you just don't care about that and you're going to throw it up there, and if it works, it works.
Yeah. Michael has also had his hand up, and I want to make sure we get to his thing if he has a thing. Oh, there. Thank you.
Hey, yeah, I was curious, like we do have versions in, I think the API paths, and then there are at least major versions on media types. Like when you think of the next minor version, do you imagine that those minor versions would show up in API paths and or media type names? And is that a way that we could allow registries and clients to either accept or deny content?
I think those types of things are tools in the toolbox, and I think they're heavily dependent on what kind of change we're talking about to be able to know whether they make sense to use them. Like if I'm pushing some new layer type and it's not a tar file, it's a .txt file or something. Or some new version of tar. They've come out with tar version 2.0 or something. That is a place where I would want to be able to say, this is a tar, gzip tar v2 format like thing. I don't think, I think that those are other like affordances we have available to us, whether paths in registry URLs or versions in media types. Those are tools we have available to us. I think they can be useful depending on what type of change we want to use them for. I think it would be useful to write down all of the places we have these affordances, right? All of the places we could make changes. And then when we are evaluating a change we want to make, we could say, oh, all we need to do is like abuse this, the semantic information embedded in this path to turn that on or off or whatever. Some of them will be more useful, more broadly useful, and some of them will be less, but those are two I haven't thought of so far. So I think writing those down is helpful.
Cool. And then like with what Steve and I've been talking about with artifacts is a new manifest type altogether. Is that something that we would expect registries to just accept under the ignore unknown fields? Or does content type, when you push a manifest, are registries allowed to be more restrictive about whether or not they accept a new media type?
I don't know the specifics of what registries, what either the spec says they should or should not allow as far as flexibility or anything. I will say to the point of having a new manifest type, I am sort of the opinion that we shouldn't invent new manifest types unless they solve some like formative foundational versioning issue. It might be, we might be circling around the topic that image spec is not practically versionable because of, prior decisions and many implementations of it. And the only way to get out from under this is to come up with some new manifest. But I don't want to jump into some new manifest type and then find out that we've also made all the same decisions that made it unversionable in practice. Because then we're just setting ourselves up for 4 years from now, coming up with some new manifest, and this time it'll solve it once and for all.
Yeah.
And we've not learned any lessons. So I don't know if that's practically what is being proposed in new manifest types, but I just want to say, if we come up with some new manifest type, I want to make sure that it is not making the same version locking mistakes that we may have made in image spec land.
And I'll just add,
Yeah.
like, the new manifest type is not expected that a registry would accept if it doesn't know how to process it. That was one of the reasons. And we are circling around the versioning. That's one of the fundamental reasons why a new manifest was created. But that is also an expectation, is the registry would not blindly accept it, because there's an expectation that if you accept it, there's some indexing happening, there's refers API, there's a schema that's different. There's a bunch of details which we'll talk about later, but I think that was absolutely a big piece of it, of a very expected, we want a registry to opt into this behavior, because there's no way to do this experience in a reasonable way, we believe, that they don't opt in. And and there's runtime components of this also, right? We don't expect the runtime to opt into an encryption model magically. There's got to be something that changes there too. So I think we're, again, just back to the versioning thing. How do we version? How do we check if we do have a versioning model for, how do you define it? How do you check an endpoint, whether it's a registry or a client? Do you support this version?
Yeah, I think that is a question we will have to answer before being able to, I don't know if we'll answer it here today in the next 10 minutes, but that is an answer we'll have to come up with to practically make changes. I wanted to mention a case where I think it is important that we exercise this muscle of versioning, and that it scares me, a particular example of how it scares me that we haven't exercised the muscle of versioning, which is, let's say SHA-256 gets broken tomorrow. That would be terrible for a million reasons, one of which is OCI falls apart. Because practically speaking, I think the spec says you can use any SHA algorithm, any algorithm you want, but practically speaking, the only one that's ever supported is SHA-256. I think it would be a useful and illustrative example to go through, how would you upgrade the spec and distribution and runtime and registry implementations and client implementations to support SHA-257, which, right, it doesn't exist, but the point is it's an example. Like, that is not, if that ever happens, it is likely to happen unexpectedly and need an urgent fix. And we are not in a position to unexpectedly make urgent fixes to things.
That's a great thing. And that's the kind of thing that I feel like could have a nice little ribbon put around it for like a working group, like very clear outcome. Like, go through this example, see what all had to be touched or broken, or expectations or future shoulds that should be in place, and like implementation proposals, and then like how would it, what would clients need? Like, really nice case in point.
I mean, I think like practically every implementation would have to be involved in that, right? Which means it's effectively impossible. But we could go through the practice of what a spec would look like that supports some made up new SHA thing. I know that the Git protocol went through a similar thing with regards to their SHAs, like MD5. Don't use MD5s, yeah, but they always thought, oh, MD5s will be good forever, and then turned out they weren't. Anyway, I just wanted to bring that up as a forcing function to think about this and to exercise the muscle, because someday we will have to exercise the muscle, and we will be happy to have exercised it earlier than wait until everything's on fire. Steve, you also have your hand up. I don't know if that is a lingering hand. I will lower mine as well. It disappeared. Was that a lingering hand?
Yeah, sorry.
Oh, okay. No worries. No worries.
I was actually curious. Like, I had to think about this more. I would hope, and I'm sure some registries crack the content, but I would hope a registry just says, don't care, just passing it through. It would, all the clients, I think, obviously have to figure it out because they're the ones actually doing something with it. But I was actually just checking. I wasn't even sure about that.
I think it would be to the conformance suite question we had before. I think it would be an illustrative practice to try to push a SHA-512 digest to any practical registry and see what it does. I think it's supposed to verify that that SHA matches the blob that you push to it. And if it's a made up hash function that I just made up yesterday, then it won't, because it doesn't know what to do with that. So I think in practice, I think you'll find that it has to be SHA-256 everywhere and nothing else is supported. And that's scary if all of a sudden the thing that everything is built on falls apart. Granted, if SHA-256 is broken, millions of other things are on fire. So maybe OCI isn't our highest concern, but I think it's an illustrative example of when someday when we might have to make a change urgently without expected, without knowing it's coming. I started a little early, so I'm totally happy to finish a little early too. If people don't have anything else to talk about, I can also keep talking about this if people want to keep talking about it. But have we come up with any sort of interesting action items? I think I will probably take
Phil,
the
you
personal
said,
action item. Go ahead.
yeah, Phil, you said something about actionable items in Slack, and if you could tease that apart, I can't hear you.
Hey, sorry. Yeah, no, I was just following up on how we started the discussion that I think it was Josh mentioned. I mean, part of the note taking was that we can not just talk all day, but have some follow up. So 20 minutes ago, you had mentioned a few things that sounded like good, next up practical items. So I just wanted to make sure we captured that. And if there was anything else that we should.
I mean, to me, the root of your whole session is what do we do about versioning so we could do anything with these? Like, I don't think anybody wants to freeze any of these specs. We just don't know how the hell to do anything. I mean, the squirting out of what you're seeing we're doing in the artifact stuff is because we couldn't find another path to move forward.
Yeah. I think if we come to the conclusion that image spec is effectively frozen because of, it is practically impossible to make changes because of the interdependencies of everything, then that would be a shame. But I think we can get value out of it by fully understanding how that got to be, so that a new thing without those problems can come into existence, as opposed to a new thing with all the same problems coming into existence. Obviously, I think my priority, my preferred outcome is that image spec is not frozen. We figure out how to unpractically freeze it, figure out versioning, move forward, and exercise the muscle. But as a fallback and plan B, if it's not possible and some new manifest type has to exist, I at least want it not to have the exact same practical versioning impossibilities. Which means like doing a postmortem and understanding how those things came to be in the first place and avoiding them in the future. I just don't want to make the same mistakes over and over. I'm happy making new mistakes. I love making new mistakes. I just don't want to keep making the same old mistakes. With that, I will probably hand it over to whoever's next and go join the Slack to see what you guys have all been talking about.
Yeah, so we have basically a 30-minute break in the schedule at this point. People can hang out on Slack, on Zoom, but
yeah,
some of us in the room will be bio break, water, coffee, whatever.
Cool. Thank you for the opportunity, and thank you for the discussion. It's been good.
Yeah,
thanks, John.
Yeah, great presentation
Jason.
and
Jason,
good
yeah.
discussion.
Sorry.
Mic issues seem to be fixed, so I don't know that we need to be able to like do a bunch of tests during like break-ish.
Yeah, if there's no more buzz, then
It seems
we're good.
fine.
Steve, no.
I think it was me. I was putting the mic down next to my power supply.
That would do it. That would do it. So don't do that. Cool. All right.
From mistakes, I think we just talked about.
Don't do that. Awesome. We will convene at 11 again, and that'll be the confidential computing group. So.
And it's fine if people want to talk over this time.
Yes.
Yeah, it can be a conversation as long as it holds the mic.
Yeah, I think Vincent, wait, is that the action item out of this, is we try to figure out how to deal with versioning across these, like categorize them and so forth? Including capturing where do we screw up so we don't do it again?
Like you say, you want to exercise the muscle. Do we have?
Oh, and that one, that's.
Do we have the proper exercise tools?
Yeah, Steve, we did take that down as one of the actionable items. If you'll see it in the
The marker that I put in the notes of like wrap up and actionable items is not a concise list of actionable items. That was just like minutes of conversation. So from that, we would draw actionable items. So don't expect that to look cleanly like a list of action items.
The SHA 512 is like a great example. Like if somebody.
Yeah, and I think we just got Blake to be approved in some of the Go Digest stuff as well. People are testing that out. So I mean, like people are actually doing this, but it's usually in isolated situations where they know they control the client and registry and the other side that's pulling the image back down. But for a general use case, what would happen if you just pushed it? I think it'd be great to tease that out. I will. Yeah, I'll be right back in just a minute. Though I'm going to take a quick break and then I'll chat.
Cool. So for those here, they moved our coffee. I think there's some kind of food right out here in the hall.
Are we allowed to drink coffee here? Or do we have to go outside?
No, we're supposed to actually stand out there.
Oh, but we can be out there.
Yeah, you can be at these high tops and drink and eat.
This morning it was inside and it was like, no, it's your last coffee inside.
Yeah, we got told we had to follow them.
Do you like a special straw you can go into your mess with?
Gosh, looking at these post v1.0.0 issues, just I want to remove them all. I know that nerd. Although I can't hear him, he's on mute. That one right
Maybe
there.
on purpose unmute. Yes,
Mr.
that was very
Bats.
nice.
Oh, yeah, probably see it better now. So, surely not everybody was kung fu fighting.
Everybody's kung fu fighting.
Well, surely not everybody.
They were as fast as lightning.
Lightning's
We'll
pretty
remind you all
fast,
this is
though.
still a recorded call.
That's the benefit, Amy. That's the what we're looking for.
We can put out a record.
Although it's been so long since I've been on a call with Mike. It was winter last time. So I had the benefit of seeing his doggo hanging out on the couch next to the fire. And I don't have this benefit now.
The futon got broken. I sat on the dog sat on it a bit heavily. The fire is actually on. It's turned down a bit, but it is actually on. It's the first day this season. So. I see Samuel's on. Samuel.
Hey, Mike.
Hello.
Hey, everyone.
Did you get my email with the suggested way of doing things? Are you cool with that?
I didn't get anything.
I sent you a couple.
Did you send? And I sent one too.
Did you send to which email address did you send? Sorry.
Let me find out.
I looped in the Apple address because Brandon let me know that like we had the wrong one. We were sending to the Intel address. This is like part of the challenge.
Yes.
Stop moving companies, everyone. This is terrible.
Yeah, so I sent one this afternoon to hopefully the new address.
Oh, okay. I just got it an hour
With a
ago.
suggestion of what we should of how we might do it.
No, sure. Yeah, I'm fine with this.
Okay, cool. So I've got slides which, as I said, I can run for 10 minutes or 3 hours or more. So I'll try and keep it to 10 minutes, and hopefully it's interesting enough that you'll have stuff to disagree with afterwards.
Looks good.
Excellent.
We've got a minute or so, and like on site will tell us when like folks are coming back in as well.
Perfect. Yeah, no, I wasn't trying to kick off. I thought I'd just check.
No, you're good. The coming in, being able to like making sure that everything works. Like we're set to go. Hooray.
It's almost like we've been here before, isn't it? And it never works as you expect, or never the first time. So, Samuel, what I basically tried to do was set up quite a lot of what you talked about to the CCC a week or so ago.
Okay.
Because I found that very interesting, and I think hopefully you can give the background that those people would already had, and you can sort of take it on from there as you wish.
Sure.
Cool. Well, I will let Amy tell me when to start.
I'm actually waiting for like Phil and those guys like start making like some sort of noise back in the room proper.
Oh yeah, we're still a minute at least before.
Yeah,
So
give it a hot minute.
Yeah.
Mikey,
They had the onerous burden of having to take coffee and then leave the premises.
We're breaking the rules on the coffee.
Good, you should.
So hey, Mike, tell us about Profian. Why we have a minute?
We're actually back. You guys do what you want. Everybody's here.
Okay.
Okay.
So,
Sorry.
Mike, you can do that as part of your kickoff. Go ahead.
Okay, hi, I'm Mike Bassar. I'm CEO and Profian, a founder and co-founder of Profian. We came out of stealth about 7 hours ago. So hello, we are a confidential computing consortium. We're some confidential computing startup based on NARCS, which is a confidential computing consortium project. So, but I'm not here to talk about Profian. I'm here to talk about confidential computing and try to give people kind of a background onto some of the stuff. So what is it? So the Confidential Computing Consortium, which is the Linux Foundation project, says that confidential computing is the protection of data in use by performing computation in a hardware-based trusted execution environment. Nice and long-winded. Some of the key things here are, firstly, we're talking about data. So one of the big questions is, do we care about the workload as well? And I think we're going to say in this context, we probably do, but it's not specific in this definition. The next thing is in use. We've known for ages that you want to protect data in transit and at rest, so on the network and in storage, but in use is about doing it whilst it's actually running and executing. The next thing is about computation. So we've had ways of protecting data, things like TPMs for a while, but computation is more complex, and we do mean general computation generally here as well. And then last kind of important bit here is hardware-based. So we're talking about hardware-created protections in what are called trusted execution environments, or TEEs. So what are TEEs? So I've shamelessly lifted this from the one of the white papers from the Confidential Computing Consortium, but it's all Creative Commons, so that's all fine. And you'll see that data integrity and confidentiality are requirements. Code integrity is a requirement. Code confidentiality is kind of, yes, you'd think hopefully type thing. And then there's some other bits at the bottom, the most important one of which we'll come to is attestability. And what exactly we mean by that we'll come to in a bit. But I wanted also to say, what are the what's out there that you can use? Well, the best known ones are Intel SGX and AMD's SEV, and they're quite different approaches. I'll touch on that in a minute or two. There's more coming. ARM9 has something called Realms, part of their CCA, Confidential Computing Architecture, I think. Intel's come out with a new one called TDX, and IBM has something called PEF, Protected Execution Function, I think. So there's stuff out there, and you can go and you can rent an SGX or an SEV bare bones machine now from quite a bunch of cloud providers, or just buy one. Honestly, not difficult. Do stop me for quick questions, but we are going to try and have sort of 10, 15, 20, 30 minutes of questions afterwards. So we'll do that. So what's the common thing? The common thing really is about encrypted memory pages. So when we look at a TE, it encrypts memory pages in such a way that even the kernel can't look in. Kernel can't look in, compromised user space things can't look in, hypervisor can't look in, all of those things. This, of course, has an impact on workload density, because if each workload has its own TE, then you can't get as many workloads on because they just can't share memory pages at all in the way that we're used to doing with containers and VMs and all that sort of stuff. And the next thing is attestation. And attestation is really, really tough. And that is basically, you need someone to tell you, someone you trust to tell you that what is running is really running, and it's really running in a T, and it's really protected. Because if someone says, give me your data and your code, and of course it's safe, you need to be cryptographically sure that that is true. And you need to work out who you trust to tell you that. And that is very, very hard. And basically, it's part of what the hardware needs to help you with, but it's still very, very hard. So we'll come back to this also in a couple of minutes. The two main types of TEs are process-based, currently only SGX, and basically you need to split your app into trusted and untrusted parts, and VM-based, which is pretty much everything else. So if you wanted to, you might think about taking a kind of standard container imaging and just doing a lift and shift and shoving it in a VM. And you might think that would be okay, but you would probably be wrong. So let's talk about why that might be the case. So how would you build an app for TE? So the first thing you could do was be to write to an SDK. That's typically the way you have to do these things for SGX. Or you could do this a lift and shift and say, basically take everything, the BIOS, the OS, user space application, shove it in one of these, in a VM and TE, and do it all fine. Another way would be you could recompile your application with some particular libraries, which are, make it TE ready. You could run a wrap around it and do it that way. Or you could have a specific runtime that runs in your TE. Now, if you do that, you've got to choose what that runtime is. What is the ABI? Is it ELF, Java? You could use WebAssembly. You could use a sort of libOS approach, or maybe containers. And to be upfront about what I'm involved with, Profion does WebAssembly. So Profion is not a container confidential computing solution. I'm not trying to sell that to you folks, because that's a different thing, but that's where we come in. So I just want to show you a couple of pictures and then discuss why things are hard. I also need to be upfront. This is shamelessly lifted from my book, which is coming out at the end of the year or the beginning of next year, called Trust in Computing Systems in the Cloud. And this is kind of what a standard virtualization stack might look like. I suspect that most people know what this looks like. It's not what you'd look like for a containers maybe, but that's kind of standard. So let's think about what happens when we put we decide to use a VM-based TE. What does it look like? What are the pieces? So from the bottom up, we've got sort of hardware-y stuff, BIOS, firmware, bootloader kernel, hypervisor, and user space. All of this stuff is your standard host stuff. None of this is in the TE yet. And of course, the host may be running its own middleware and applications and all that sort of stuff. But within the TE, you've got a whole bunch of layers. You've probably got a BIOS, you've probably got a bootloader, kernel, user space, middleware, and application. That's if you're taking a standard VM. So just the first question is, who puts that in there? Who decides that it's safe? Let me ask some of those questions around here. So here are some of the trade-offs and complexities that you might be thinking of. I've only got 2 more minutes, so I'll try and be quick. So firstly is, are you providing your own BIOS? Because mostly when you go to a cloud service provider, CSP, you take their BIOS. And as soon as you take their BIOS, you can't have full trust in your TE, because you can't be sure what the BIOS is doing. So that's question 1. 2 is, surely TCP size is important. If you do a standard lift and shift of a full commercial VM, with maybe Linux OS and maybe a hypervisor, or lots of user space and all those bits and pieces, that's a complex thing to worry about. The next thing is, who attests? So who is going to let you know that what that TE is and what's in it is what you expect? You're going to need to have a measurement of something, and something's going to have to do the measurement, and something's going to have to give you that measurement. So generally, you might say, I only want to trust the CPU, but how do I then get the measurement to a machine which is somewhere else on the network? How can I be sure that nothing else has messed with it? Do I trust my CSP to do the measurement? And if so, what's the point of doing this in the first place? I'll leave it there. Where is I/O managed? Do we trust the host to do I/O, storage, networking, routing? What about sidecars? Where do they fit in this world? Then the question of where the images come from, the things we're putting in the TE. Where are they stored? Where are they encrypted? Who decrypts them? Are they signed? How can we be sure that what you're running is what you care about? And the last one is, what's the unit of isolation? If you're taking a sort of a libOS view, your application is a particular small piece, and you're collapsing your middleware, user space, kernel, bootloader, and BIOS into basically a libOS. But if you're doing more than that, do you want to have a single container as the application, this thing in the TE, and have cryo or something below it, or what does that look like? Or do you go with a full pod, or how do you do it? And these are some of the questions and complexities that you really need to look at. So I'm just going to say, if you're interested in NARCs, we'll make the slides available. You're very welcome to come and have a look at it. Profion is a custodian, Apache 2.0, Rust, and assembly, WebAssembly runtime. It's hardware agnostic. And I'm going to stop there because that's my 10 minutes. Whew. Could people see that and hear it? Because if not, I've wasted 10 minutes of everybody's time.
No, you were good. You were good.
Okay, cool. That's a relief.
We could hear you, Mike.
I'm sorry it's quick, but I had a lot I wanted to get through. So Samuel.
All right. Let me share screen as well. I'm hoping you should be able to see
Looks
something
good.
now. Okay.
Looks good. Mash present.
Yep, you can see it.
All right. So just to jump on what Mike said, and especially on the list of opens and questions that he raised at the end of his presentation, I think what I just like to briefly talk about is the opinionated way that we decided to go with Kata containers to build one approach. And I think Mike said that NARC is one approach. We're looking at another approach. I don't think they conflict at all. I think there are two different approaches with probably different use cases. And here, what I'm going to talk about is, well, doing confidential computing for containers with Kata containers. And Mike's last slide was pretty good because he like highlighted all the questions that we're asking ourselves, and we're trying to give some answers to those questions and follow a path and try to see if that works. Okay, so this is this is something I presented at Plumbers last week. So for those who were there, apologies for this. And for those on the call who are not familiar with Kata containers, this is pretty much what it looks like. In a Kubernetes context, it pretty much looks like a regular runtime, and it's actually completely transparent to the upper layers. The difference and what Kata containers does is basically building a virtual machine as light as possible, as fast in booting as possible, and putting a Kubernetes pod inside this virtual machine. So it talks to a VMM, typically calls into KVM and so on. And it builds a virtual machine and runs the containers, container workloads inside this virtual machine. But obviously, the container images are still on the host. They're exposed into the VM through VirtIFS and so on. So that's the current state of affair. And we're trying to build confidential computing into Kubernetes through Kata containers as one solution. And really what and I want to insist on what Mike was saying is that the goal for all this is to say we do not want to trust the host anymore at any level, sorry. And so there are a few issues and contradiction between what we're trying to do and the current architecture. And this, last but not another point is the VSOC-based communication between the Kata containers runtime and the agent running inside the virtual machine to forward some of the kubelet and CRI commands. Okay, so that's the red model. I'm not going to go through that. So if you look at the current state of affair and the current architecture for Kata containers, and there are like at least 3 points that are contentious and that are preventing us from implementing the confidential computing model. Those 3 points, well, the first one, and I think the one that is the most interesting one for this call here, is the container images. So right now, the container images are living on the host. They're completely visible to the host, and they're exposed through power virtualization into the guest. Well, the point of computational computing is to hide the container image and to make sure that container image and essentially container workloads are not exposed to the host. That the host should not be able to not only tamper with the container images, but also should not be able to see what's in the container images. So having those images in the host is a big issue here. The second one is, and that kind of goes back to the question what Mike was asking, so who is attesting? And we need to attest, we need to verify that everything up to a certain level in the guest is measured and attestable and is running exactly what we're expecting. What we, and by we, I mean the guest owner, the tenant. The tenant needs to be able to verify that everything up to a certain level in the software stack in the guest is measurable and attested and maps to what he or she expects. And the last one is the VSOC communication that we currently have between Kata containers and the agent. Currently, we use this VSOC-based API for example, execing process into an existing pod, which is something obviously you don't want to do anymore with if you want to build a real and practical confidential computing threat model. You don't want kubelet or any host component to be able to exec anything into your computational computing container. So those are the 3 main contentious points that we are seeing for implementing confidential containers with Kata. And the way we'd like to implement this and the way we'd like to address those points is this one. So first of all, we are building a model where instead of having a container image, the container images and the container image layers living on the host, they would be pulled and kept inside the guest. So the guests would be responsible for pulling the images and keeping them inside the guest. The guests uses encrypted memory that the host cannot tamper with or even see. So we can keep the container images on memory, but we can also use alternative for this, as memory in the computational computing context is a very scarce resource. There's a lot of density issues with computational computing, so we don't want to waste more memory for storing container images. So we're looking at an alternative solution for this, but definitely the image layers would be pulled from inside the guest. We only want to use signed or encrypted container images. My personal view on this is that they should be signed. Sorry, they should be encrypted. If you only sign the container images and you pull them through a networking layer, a fabric that's controlled by the host, essentially you're giving the host the ability to look what's being pulled and look into what your container workload looks like. Then we want to attest the guest. So we want to be able to attest the guest up to the point, up to the software layer that does the container image pulling. And that will be in our architecture, this will be the Kata agent, which is part of the Kata containers virtual machine initRD. So what we're saying is that we want to attest the guests from the bottom. That could include the firmware up to the initRD image. We don't want to attest the container images because they could be very large potentially, and attestation latency can be at least in some can be proportional to the size of the artifact that you're measuring. So measuring a 4, 8, 16 gigabyte container images is going to have a huge impact on attestation latency and on boot latency. Once the guest build the attestation and you're able to attest your guest up to the Kata agent point, you can provision the guest with the container images keys, the signing or encrypted keys. After you've been able to typically remotely attest that what you're running is what you're expecting, your guest owner, the tenant, upon attestation success, will provision will establish a secure network layer between the guest owner and the guests, and provision the guests with the encrypted keys. And last but not least, we want to be able to restrict the exposed API that goes through the VSOC layer here, so that we can allow only a certain part of the CRI/Kubernetes API. So if we put all of this together, this is the again high-level architecture that we're currently working on. So this is I want to I want to be clear that this is a work in progress. This is something that as a community we're building. We're getting quite a bit of contribution from different cloud providers that are interested in that model. And basically, the guest agent would be talking to an attestation agent. The guest agent would be responsible for pulling encrypted image layers, and then offload the key provisioning attestation part to an attestation agent. So we're using OCI Crypt for this, which is a project that IBM and a few folks started in Go, and we are re-implementing this in Rust because all the agent in Kata containers is implemented in Rust. So we're using OCI Crypt to talk to an attestation agent that also is implemented in Rust. The attestation agent would be responsible for building the quote, getting the quote from the hardware, from the computational computing CPU, and send that code over to a attestation service. The attestation service is responsible for verifying the codes, basically making sure that everything up to everything, including the init.rd image in the VM, is what it's expected to be. And if that is the case, provision the agent, the guest back with the container encryption keys. And at that point, the Kata agent with this newly provisioned encryption keys would be able to decrypt and then unpack the container images inside the guest. Again, one optimization that we're looking at is building a model where we would also use that key if the host provides us with a temporary / ephemeral block device. We could encrypt that block device and keep the container images in those encrypted block devices, something that the host, again, would not be able to tamper with or see. And also we're changing the way we configure the API between the runtime and the Kata container agent inside the pod, so that as a business decision, you can select which part of the API you want to support. And I'm saying this is a business decision because depending on which part of the API you want to support, it will decide what kind of Kubernetes workloads you want to support. So if your workload and your workflow, your business requirement expectations require you to be able to, or require anyone to be able to exec something into your pod, then that's up to you to decide if you want to support that with confidential containers or not. And exec is just one example of many of the endpoints that you could disable through this configuration-based API restriction. So that's the current approach that we have. There are obviously some limits and restrictions to it. As I said, depending on how you restrict the API between the Kata runtime and the agent, you would be restricting the set of workloads that you support. There are some boot latency issues to be taken in account. Before we can actually start the container workload from the container image that we decrypt, we need to attest and get the keys provisioned. So that definitely adds to the latency, to the boot latency. One, I think, not major, but really one issue that we obviously are introducing with this approach is that container image will be duplicated across pods. You could think about being able to share encrypted container images between across the same tenant, but still there will be quite a bit of duplication of container images. Sidecar containers is another issue. How do you run sidecar containers? How do you decide if you want to start a new container dynamically alongside your expected workloads? Do you require this container to be signed as well to be encrypted? Those are opens that we are bringing in with this new architecture. So I think for this audience here, for this forum, I think the most important part is that we are building all of this architecture based on the container image encryption specification that is not really approved yet. That's still in flux, in discussion in the PR. But definitely our computational containers architecture is heavily relying on this specification. And I'm done. I hope I didn't go over time.
You are perfect.
So I believe we're kind of trying to be a panel now. How long do we have, Amy, or whoever's in charge? Oh, Steve's got a question already.
You have until the top of the hour, so rock and roll.
Okay. Steve was first, I think.
Yeah, it just Zoom does keep track of the order at the top, so that's helpful. So yeah, I was just curious. I mean, there's two fundamental pieces to it. There's probably three from the build side as well, but we don't really represent. I don't think anybody here represents how we build containers or build content. But once content's pushed to a registry, the idea, I guess, is it's encrypted, and you shouldn't be able to crack at any. Even if you got the content out of the registry, unless you have a key, there's nothing you can do with it. Is there anything special that you think you need from the registry side around the encryption part to keep the encrypted content there, or am I missing something else?
No, at least in our case, we're not expecting anything except. Actually, we are openly saying that the registry can be completely untrusted, as long as you can take any registry and as long as you can upload your encrypted image there, that's a supported model.
When you say untrusted, do you mean that you would also support public images or only private?
Public images, yes, yeah.
So what does that mean to have an encrypted public image? Is the key, what's the value? If anybody could decrypt it, what's the...
Oh, sorry, maybe I misunderstood, Mike, but I thought by public registry, it was saying that it was meaning to say a registry that is not controlled by the tenant, or maybe I misunderstood.
Well, yeah, no, I think what I was trying to ask is if I had a pod spec that had some containers that were public, some that were private, would that work in your model? Where like the pod spec is using your cat containers runtime.
Well,
your CC runtime.
In that case, my understanding is, I mean, I'm not part of the project, but basically you don't care about the confidentiality, you only care about the integrity. So it's actually the signing that you care about more, although encryption, because it comes with a key, does give you both, right? If you use the standard models of encryption. So I guess that's the answer. Samuel, is that fair?
That's correct. If you want to use a public image, you should still need at least you should be able to verify that this is the one that you're expecting. If
Yeah,
it's
I'm separating the signing aspect, right? The integrity of the content is like another layer. I get that, but I'm just trying to say, like from a registry operator perspective, whether the image, whether it's anonymously pulled on something like Docker Hub or not, I think I'm just assuming. I'm trying to make sure that the concept here is that even if I pull that image, unless I have the key, there's nothing I can do with it. Like the idea is that it's kind of sealed up and it's encrypted for specific use.
That's correct.
And how I get the key is probably an external. I don't know how you get the keys to be external, but is there anything that you're seeing that's missing from being able to push and pull these to private or public registries?
I don't think there's anything missing. It's just, as I said, that it's heavily relying on a specification that's still currently being discussed for the encryption part, not for the distribution part, at least.
Right. So
From
to get it out of the registry, the client needs to, the various hosts need to know how to process it. But okay, cool.
Yeah, the kind of thing I'm trying to get out of this is, do we need an attestation key, header, for example, to be used in a distribution API when we do the authentication? We haven't specified how authentication works yet in OCI, but it sounds like it might be important to your environment, to your CC solution here.
How would it be? That is curious. If I have pull rights to the registry and I could pull your image, then what additional authentication is needed? Because the idea is I can pull it, but unless I have the keys to decrypt the layers and decrypt it so it can run, it doesn't matter. All I need is pull rights. In fact, even if I don't have pull rights, or sorry, even if it's anonymous, I still can't do anything with it.
That's right.
So Michael,
I don't. Yeah, go ahead.
No, there's a piece there that I'm missing. I'm curious what addition.
I don't know. Maybe Mike can expand, but at least in our model, we're not expecting any authentication when pulling. So it can be anonymous pulling from a public or private registry. If you get the container image, you're not going to be able to do anything with it because, well, you don't have the keys. Those keys are coming from a relying party, as you have full control on where the keys are stored, generated, and so on. But what we're saying is that where the container image is stored and how it's pulled is completely outside of the trust boundary.
So I think there are at least 3, possibly 5 different keys, or keys being used for 3, possibly 5 different reasons, shall we say. So the first one is to protect the integrity of the image. That is, you want to be sure that what you're taking is what you thought it was, right? And no one's messed with it. That's a property you want for public or private images.
But that has nothing to do with confidential computing, right? You want that across all your content.
Well, I would hope so. Yes.
Yes.
But yeah. So the second is confidentiality of the image, and that is only relevant for private images for which you have a key, i.e., which you can unlock, do stuff with. Yeah. So those are the first 2 things. Then there's the question of attestation, and you need to somehow, and I don't know how confidential containers do this. You need to be sure somehow that the thing that has been set up for you to put container images into is a proper thing. And by that, I mean 2 things. One, that it is a proper TE that you accept. Let's say an AMD SEV SNP container would be one type, right, of generation of Milan or Naples or whatever. So that's one thing. I also mean that the thing that's running inside it, i.e. the pod and the guest agent and all those bits and pieces, are also what you think they should be.
Yeah.
Because if you can't be guaranteed of those 2 things, you should not be deploying anything to that pod. Yeah. And then there's two other possible keys as well. And that is 2 properties. And that is the confidentiality and integrity of that image as it goes across the wire and is loaded into the pod. So there's 2 ways of doing that. One is to say, sorry, at least two ways. Okay, sorry. One is to say that you put inside the pod the decryption keys associated with a particular container. That's option one. Option two is that there is another key which the pod has, and your encrypted container is going to be encrypted under that key. If you do that, you need another external trusted party between you and the pod who's going to decrypt and re-encrypt. Now, that may be a model you like, it may be a model you don't like, but you have to decide who that party is going to be. Is it Kubernetes? And if so, which bit of Kubernetes is it? Or are you going to say, for all possible images that I might want to decrypt, I'm going to ensure that the correct key is in the pod. Now, it could be more complex than that, because if you really want to be clever about it, you could actually use an M of N scheme and say that actually, as long as it has one of several keys, it can do that. But now we're just getting a bit esoteric and crypto-y. The problem still remains that either you need to have a key inside the pod that knows how to decrypt all possible containers, images, or you need a trusted party outside the pod that can decrypt and re-encrypt. Sam, is that fair?
That's fair. And the model we're looking at is the former. Sorry, the latter. So basically, we want to have an external relying party that would provision the keys for the container images for the specific container images that we're trying to unpack, and we need to decrypt them before unpacking. Right. So
are you using your own use case or your own manager for those keys, or is that like kernel key ring or IMA bits so that what it's writing are different namespace or different partitions within the host,
for now we're keeping the keys on in RAM, in encrypted memory, which is basically something that only the guest can see in that model. So RAM is encrypted in such a way that the host doesn't have access to it. So you can keep the keys there if you want to. So that's the current approach.
So I was looking at this from the other direction. You've got the requirement you want to encrypt everything, and that's an awesome requirement. I like seeing it go in that direction. But thinking of potentially what we have today where things are unencrypted, could you run this with a registry that you trust instead of on an untrusted registry, and then have it just signed so you know it's valid going across, and then TLS encrypted on the connection there, HTTPS, so that gives you that secure transit into your thing? Are you then secure from the host seeing that?
I don't think we are, because essentially, well, I mean, you're going to be running, for example, over like a VirtIO-based networking endpoint, which is entirely controlled by the host. The host provides you the backend of your networking implementation, so it can do anything it wants and make you believe that this is a TLS-based. Everything is encrypted between you and the trusted registry, but it has entire control on the networking control plane.
So that's one of the questions sorry, Sam.
Yeah. No, go ahead.
That's one of the questions I raised in my set of questions is where do you keep the IO, right? Because this is exactly the sort of problems. So an alternative approach is one we've taken, which is that we are going to in the NARCS project, we say we're going to let the host do the IO, but we're going to do key management at a level above. So we're just going to have TCP connections from to the host, and we're going to basically encrypt over that. So we'll set up the stuff, and we'll just take a socket from it. But then you've got a chicken and egg problem about how you establish those keys in the first place, and that is not simple, particularly in a more complex setup where you've got a full pod.
Yeah, the second half of that is, I think in the very beginning we were saying we wanted to trust the data was secure. And a lot of times we think of the container images as not the data, but they're the applications you're running. And so depending on what's in that image, there might be an opportunity there to run a verified image that's signed, but not encrypted. Anybody can see it, anybody can look at it, but the data that it runs on that it's using would be the thing that's secure. You know, it's the credit card numbers for the user or something like that. That's the part that you want to keep locked down.
Yeah, that's kind of the SGX model where it's process based, and the data that you typically want to secure is the one that you generate, not the one that you're pulling. So you'd basically pull something that is completely, there's nothing critical there, and you just need to sign it and to be able to verify that it's the right thing. And you don't care about the host. You don't care about the host seeing it. But I think the thread model that, oh, Mike, yeah, go ahead.
No, please finish off. It's difficult. We've got a bit of a lag.
Yeah, the thread model we're trying to build here is where we're saying and there are use cases for this where the container image contains itself confidential data that you definitely don't want the host to be able to see in any way, shape, or form.
Yeah, so, and I just to go on that, I think what counts as data and what doesn't is kind of getting a bit fuzzy these days with AI ML workloads, but also you need stuff like configuration data, not to mention, you know, cryptographic keys and stuff, which I'm afraid do turn up, as we know, in images, are all, you know.
I try really hard to tell them not to put it in the image, though.
I know everyone tries people really hard, but yeah, anyway, but the point is that, you know, there is a fuzziness there. And, you know, if we're going to try to make it as difficult as possible for people to do the wrong thing, we can never force them to do the right thing, but we can try and make it difficult to do the wrong thing. Yes, there are absolutely use cases where, and this is, in fact, one of the things that the CCC, the Confidential Computing Consortium, the definition I used at the beginning, doesn't require confidentiality of the code as part of the definition of a TEE, for basically exactly this reason, in that there are some schemes where you don't guarantee it. But in most use cases, it's a desirable property, a strongly desirable property.
Encryption is definitely nice. It comes with those downsides if you no longer get to dedupe the layers and other challenges like that.
Yeah,
so
and key management, as we've already discussed, right? These are, you know, the overhead's not too bad, honestly, in terms of the performance overhead these days, and particularly, you know, AMD and folks have designed these schemes so that it's not too bad. The overheads we're seeing are not too bad. You know, low percentage figures generally. Although, of course, you can push that up if you do lots of exits and, you know, VM exits and stuff, entrance. But yeah. Indeed.
Yeah, I'm just thinking of a tiered approach because some people like Steve will want to have low storage requirements on storing a lot of these images. So maybe there are some cases that don't need it and other cases that do. But that's all I got. Go ahead, Steve.
I missed the low storage aspect of it. What was that? Sorry.
When you encrypt the image, you can't dedupe the layers anymore. And so at that point, you're going to blow up the amount of storage on the registry. So I was saying people like you might care about that.
I mean, we just try to pass it on for the customer so they can choose. I mean, I do wonder if I guess if you're pushing, I'd have to think more about that. I mean, that's a customer choice about what they want to do, and there's a value there, I guess. There's a value there. So yeah, the deduping is an interesting one. The question I have for you is also kind of, again, that end-to-end. What is the expectation, kind of the versioning conversation we had earlier, if I'm on a normal Kubernetes cluster and I pull an encrypted image and it doesn't know how to run it because it's not a, you know, whatever container, I'm not even going to try to get into brands. What is the expectation? Does it just fail? Does it gracefully fail? Is the user expected to know that this thing in the registry is an encrypted container? Is there something on it that says, by the way, this is encrypted with this key? Not that not that there's enough disclosure to decrypt it, but to at least know, like, oh yeah, that's the foo key that I have to figure out how to get. Like, what kind of information, metadata is available for the end-to-end experience and discoverability?
I would say that this, how would I put it? It's basically, we don't expect, even today, if Containerd pulls an encrypted image or Cryo pulls an encrypted image, we're expecting it to gracefully fail and tell Kubernetes back that it's an image that it cannot decrypt.
Does it know that it can't decrypt it, or is it just fail because it can't decrypt it? Like it doesn't
So
know
with
it's encrypted or it's just corrupted. How does it know the difference?
I don't know about this, but I know that when you run Containerd in conjunction with OCI Crypt, then decryption failure. I mean, OCI Crypt will know if the key is available or not, or if the decryption actually failed. So it definitely knows how to distinguish between those two failures. I am not sure how this is propagated up to Kubernetes, to kubelet, to be honest with you. Yeah,
I'm kind of getting that handshake that we were talking. Well, like you weren't in the other session. If I try to pull, foo:1, does it pull because it doesn't know any different that it might, or does it get to the client and only on startup does it fail, or is there some expectation that I'm not going to try to pull this thing because it's not what I expected it to be?
Yeah, I think sorry, go ahead.
No, go ahead, Mike.
Yeah, I think the idea here is that we'll receive a runtime on the pull request, and that runtime pull request will be reflected down into the implementation, right? Currently, if you were to ask this, we don't really know what the runtime is for. When you do an image pull request, it's at the node host level. So it's cached locally, and when we do a pull with unpack, and if it's encrypted in that, because that's set up, then it will be decrypted. And if we can't, because we don't have the right key, it will fail. And we will report back the error all the way up the chain. Is that the question?
And the media type says it's encrypted, so.
Sorry, go ahead, Brennan.
I was going to say the media type says that it's encrypted in the media type, so you would know from that you can't run it with just a regular runtime.
But is it the layer that's encrypted or the manifest? Not that the manifest is encrypted. I'm just saying, does the manifest say, hey, by the way, I'm an encrypted thing. If you don't understand encryption, don't bother pulling it. If you don't have the key for this thing, don't bother pulling it.
It says it in the manifest. The manifest is not encrypted. It points to objects that are like media typed encrypted, like specify that they are. So any client that's doing a premature fetch could actually have like an encrypted layer among non-encrypted layers even, and it would be able to sniff that out before it actually goes to unpack it, everything else.
And that's indicated on the layers collection, the layer media type.
Yes.
Okay. So the manifest itself doesn't know. What I'm trying to understand is, because we're doing the same thing in the notary signing scenarios, is we're trying to put some piece of metadata up on it so that it says, I am signed with the Acme Rockets key. So the client could say, well, I don't have that key. I know I'm not going to be able to validate it. I'm not even going to try to pull it. So I'm curious if you've thought about that and like how you've handled that in the encrypted situation, or do you just pull it to the client and then figure out as you start to do the runtime?
We pull it to the client and then we figure out, as far as I know.
Okay.
So the manifest though has annotations for all the keys and whatnot that you want to attach, right? I believe that was the
yes.
implementation. So as soon as you pull the manifest, you know whether or not you can decrypt it when you're pulling the layer. So you don't even try to pull that layer without being able to decrypt it.
You have enough information to decide, is what you're saying.
Yeah, you could definitely implement what you're describing, Steve, and say by just reading the manifest, you should be able to say that's a key I have, or that's a key I don't have, and I'm not going to bother pulling further because I don't have that key anyway. And that's one of the reason why the manifest itself is not encrypted, I believe, because there's, I mean, you could think about well, having a layer on top of the manifest for decrypting in the manifest itself. And the reason why I'm coming to this is because we thought about another solution for Kata containers where we would pull the container image in. We pull and keep it in the host. What we're saying is that if it's encrypted and the host doesn't have the keys, we can surely keep it on the host and starts actually deduplicating. If a tenant is launching 200 containers of the same image, you can save quite a lot of space there.
Mm-hmm.
But the problem with this is that the manifest is not encrypted. So the host could decide to mess with that and kind of change the layering, kind of remove some layers and basically tamper with the actual container image unpacking process by changing this manifest. So because of the fact that the manifest is not encrypted as defined by the currently being discussed specification, that's a solution that we don't want to implement. We don't want the host to be able to mess with the manifest, basically.
Yeah, I'd add an extra thing to that, which is that it's not just about the host being able to mess with the manifest piece. It may decide to interfere with the running of particular pods if it knows that they're adding particular containers or types of containers. If it's seen them before, if it says, okay, I've seen before that this does this thing, I can decide to do a resource starvation attack, which is very easy.
So poking on that a little bit more. So it sounds like you're surfacing the annotations, and that's great. So we've had it support what we call customer managed keys, right? So as a multi-tenant service, we encrypt it with Azure keys, and then customers say, that's great, but I want my key. So what I always call is the Coke and Pepsi scenario is Coke and Pepsi have different keys on top of the keys. So it's double encryption at rest. The challenge we always get into is what is the stuff that is guaranteed to be encrypted by the customer versus not, so you can actually understand it. Annotations has been an interesting one, or even the media types. So is the expectation that anything that goes in the manifest is not encrypted, and you should not put stuff in the manifest that you expect to be encrypted, because that is the communication line between the secured encrypted part and the rest of the system that needs to understand these things more generically.
Yeah, I think you're not expecting in our model, at least, you're not expecting to put anything that's sensitive
right. Okay.
in the manifest itself. Yeah.
Cool. Did we really end with 6 minutes early? That can't be.
Well,
I too was a little surprised.
I'm going to ask a little question in there, which is around we talked about issues of density, but also I mentioned TCB. Are there opportunities? Well, but yeah. Are there opportunities to be pushing people to reducing the size of the containers they're putting together, given the impact, the negative impact that that's going to have in this sort of context, which is significantly more than it is in a non-encrypted one? I mean, in my view, anything which reduces the size of things going across the wire and being, is good, and it reduces attack surface, and there's the whole supply chain thing as well. I wonder whether we're going to be lucky with that, or whether just things will keep getting bigger and people ignore it as they tend to over the years.
I mean, size, well, I won't say that, but yes, the bigger these things are, the more problematic it is across the board. And what I was going to say is, if it's not any worse than ML images, then you're probably fine. The problem is ML images are things that people want to encrypt to keep their intellectual property. So for for a lot of reasons, but the ML community seems to have some of the biggest multi-gigabyte layers and total images that I've ever seen that are breaking things left and right at times. So when you encrypt something that's already over the top, yeah, it is a problem. I don't know if we should just, I mean, at some point you do need to just support more bandwidth, more size. You know, pictures have more density, you know, we want better quality pictures. There's always the evolution of things increasing, but I think you always need to have that balance of, does it really need to be that big now? Can we optimize this? As opposed to, hey, I'm just inheriting from layer one, from image one, from image two, from image three, and it's got every package in the world in it.
Yeah.
And then they just yell at us because something takes too long to run. It's like, it's 20 gigabytes in size, really?
Yeah, and one thing that Samuel noted as well is the time it takes to measure and therefore attest things, if you're doing that, can be linear with I can see it being worse than that on occasion with the size of the thing you're trying to run. And that is not a good thing. I mean, if you've got multi-gigabyte images, right? I've heard about sort of half terabyte images for these things. It's just
and that's the reason why we were saying that we want to keep the measurement up to the initRD image. We do not want to measure the container image themselves. And that is the reason why we're saying we need to encrypt those images, because they're actually not measured. So the only reasonable way for us to verify that the one that we're expecting is encryption, because they're outside of the measurement surface. Sorry, go ahead.
There are some other proposals that are looking at how to change the image file system layering design to only pull what you need. When you say I need to run this binary, it pulls that one binary down. And so it might be an interesting thought process to see, could you add encryption to something like that, or combine some of that logic with encryption? That way, even if the image is large, you're not pulling the whole image when you first run it. You're only pulling the pieces out of it that you need.
Yeah, encryption at the block level is, I think, what you're kind of getting at. Whatever that block size is defined as, a file, a layer. And the deduping is an interesting one also. Like I'd be curious if this is part of what Brandon was based on, because the deduping is not just the storage on disk, but when a node is pulling it across the network, can it say, I've already got that one? So obviously, if the same Debian layer, I'm just picking on it, is encrypted with two different keys, those aren't the same. But if I am, and I don't know how much this is the case, do customers wind up using the same key for multiple images? And if so, if two images share the same layer and they're encrypted with the same key, do those get deduped? Not just in storage, but do they have the same digest? So when the host pulls it, is it already to kind of recognize it's already on the node? Or is that secure boundary you were talking before, that you don't do any sharing?
I don't in our proposal, we don't do any sharing, and the host actually does not pull the image. So the image stays in the guest, which has a quite a bit of architectural consequences on, and Mike is fully aware of this. Because now when Kubelet basically is being asked to pull an image, it doesn't know if the image is there or not. It needs to be able to talk into the right pod to understand if the image is there, if it needs to ask the guest to repull it or not, and so on. So it's the high level diagram that I put there, that I shared, is just the tip of the iceberg. There's some consequences on how container image management, not only layers, is going to be implemented for this. And Mike gracefully is helping us with that.
So I've got a dash. I want to say thank you, everyone. This has been lots of fun. It's really interesting to see different projects making different choices and the reasons they do that. And it's always good to have sort of some crosstalk and that. So if anyone ever wants to find out more about confidential computing generally and sort of the underpinnings and how we're working together and some of the different things, you're very welcome to attend Confidential Computing Consortium meetings. They're all open. Everyone come along to them, and we'd love to see you. So thanks for having me. I really appreciate it, folks.
Yeah,
thanks.
Thank you. Thanks, both of you.
Bye. Thank you.
Sam, if you happen to have your slides in a shareable form.
Yeah.
Pass that
Okay.
along, and we'll put it up on our HackMD so people can check
Yep.
it out later. Yeah, thank you.
I'll add it to the Acandi.
I've already pestered you about this by email, so
Okay,
good.
cool. All right, dinner time for me.
All right. Yeah, we
Thanks,
are
everyone.
on break until 1:30. Everybody looks very much on break. Yes. Okay.
Thanks, folks.
We'll see you back then. Bye all.
Italian place down in the lobby that was pretty good.
No, we're on our own for lunches.
I realized that my video was off. I was waving at people. What a goober. Oh, well.
Yeah, we saw you. It was your face and hand was waving on the big screen. You want to come down and join us virtually, Vincent? We could put you on a phone.
No, it's okay.
Is it spaghetti and meatballs, or is it just?
I think they have that too. They have pizza and other stuff down there. So I don't know how food will go across the wire, but enjoy lunch, folks.
Virtual pizza for everybody. Yeah, Steve, if you got some questions about how we're gonna do this image stuff, give me. We can talk later.
Yeah. Don't leave anything that won't get stolen. Okay. I'll leave you the mic.
It's not going to be easy.
What's that? Should we eat together or should we? Yeah, I mean, yeah. If you want to come here, I think that's. Yeah. I'm going downstairs. The Italian place is pretty good.
I'll mute him. So, John, you gonna hack emoji some?
I was thinking about it. I don't. Code generation just doesn't really get me going. So, like, I've not got any interest in contributing my little hack to it, but maybe next April.
That's fair.
Will that be April 1st or?
Yeah, exactly.
Looks like I was doing this in May last year or this year, so I missed it by a week or two.
Missed it by that much.
Thank you for relicensing, Vincent, so I can use it.
That's how it works, I guess.
What are these she digests, and why is it smiling at me?
I wish the corpus had been just twice as large. Like, it's still pretty long set of emojis, but I know it's a hard trade-off to hit.
You wish the corpus would have been what?
Larger so that the string would be shorter, but I'm balancing the corpus versus the length is, I imagine, really challenging. And I'm sure you did a lot of original research to figure out the optimal balance.
Oh, of course, it was a heavy research project. No, it was truly just the smallest set of cutting it in half even.
I didn't check. Was that actually a Unicode set that you guys were creating or proposing?
It was a joke, literally. I
Okay.
just submitted a conference talk about it. I think after it was around the time that we were approaching the 1.0 of some of the specs. My brain was like leaking spec language out the side. I started laughing with a coworker about doing this, and we made something that looked like a spec and put it out there, and then like immediately somebody contributed a Python implementation, and then somebody else contributed a Rust implementation. And
X is so boring. Let's move on.
I mean, it surprisingly has like this much merit in that like most everybody, I mean, obviously, unless you're running like SHA-1 sum -C or whatever, most everybody looks at like the first 4 and the last 4 of a hash and calls it, you know. So even if you just looked at the first 2 and the last 2 emojis, you'd probably remember them slightly faster than the hex. I don't know.
That's why we rely on the bit avalanche.
It's fair. The bit avalanche cascading hashes really helps. But something that's very quickly just visually distinguishable.
I'm going to turn off my video to eat lunch and not offend anyone, but I'll be sitting around.
At this point, I might actually have to switch to walking around mode. This is usually when I finish my day and have a load of other tasks and duties that I need to do. So might be just in earplug for the rest of the meeting.
Sounds good, Vince. Cheers.
And before anybody grabs a microphone in the big room there, the screen share on that side has the mute set.
Yes, I've noticed that, and I am going to like I can see they're still getting set up over in there, and Lasker
Yeah.
just posted like 4 minutes ago that he was still coming up the escalators, so we're getting a slower start.
Yeah, I just figured in case anybody picked up a mic and started talking, let them know if they've got the.
Yeah, and Open Containers is also saying we don't have sound yet, so I'm not sure who is the there are a number of open containers running around.
Yeah.
Okay. The guy needs to unmute everything. All right, cool. We'll give it a bit.
Okay.
It's better.
All right. Hey, folks.
Also better. Super. Okay.
Okay. Walking in the rain took a little longer. So thank you for the patience. All right. Well, this was actually wound up being a good sequence of events, I guess, between Jason's talk and the conversation kind of around versioning and why and where we're at, where we are. So let's see. I think the thing that I wanted to start off first was just, I don't know if anybody's has sushi or understands the history on why you're given ginger, and it's actually about cleansing the palate, kind of a transition from one thing to another. And I just wanted to try to take this as an opportunity to, we wanted to be able to take a moment and really talk in depth. This is something that's obviously been going on for a couple of years now on the discussions we've been having around how do we support other things in a registry. And now we're trying to take that next level of not just storing other things, but establishing relationships between them. And everything that Jason was kind of talking about earlier has been the things we've been bumping up against the whole time. So I wanted to kind of take a step back and not just talk about some of the technical reasons why we've done things, but what it is we're trying to achieve. So, and also what is, why did we take certain approaches? So I really just wanted to kind of take a step back and just kind of think about a couple of things, because I know we've often talked about design A versus design B, and what makes the difference between those. So I was trying to play a little bit with some of the Seattle thing of what is the best design? Suspension bridge, cable bridge, floating bridge, or a tunnel. So what would the best design be? Right? What's the answer to that? Well, I'm trying to have a little interaction here.
They're all good.
They're all good. And I guess they all can be good, right? They all can be good, but it depends, right? The requirements really do clarify what the design. They're all good designs. It's just a matter of which design applies to what problem. So I really do need some engagement besides Joshua. I don't know if people hear him over there, but if I'm going under downtown Seattle, what's going to be the best design? I don't know if I really want to put a suspension bridge across downtown Seattle. And, so we had Bertha. And Bertha definitely had some problems trying to get through downtown Seattle. But if you get a chance, if you've ever been to Boston back in the day when all the elevated roads were back there, it was not, the most exciting city at times. Where if you go back now, all of those roads have been taken out. It's absolutely beautiful. They're all green spaces, and that's what the Seattle waterfront is starting to turn into. So that was the best application there. In Common Narrows, it's a large span. It's got a shallow bottom. There's large boat traffic that has to get through it, right? So in this case, suspension bridges turn out to be the best design for that. Now, this is another example of suspension bridges were the right design. Turns out the first one didn't go so well. And there was definitely some problems that were a little catastrophic. There's some great videos to always look at Galloping Gertie there and before it collapsed and people walking across it. So in this case, the suspension bridge was the right design, but they didn't realize the wind load that impacted it. So even a good design still may need some learnings to go along the way. So now it's actually got a pretty nice bridge, and you can get across, and it's wonderful. And the last one, I'll just mess with Lake Washington. Lake Washington's kind of an interesting one. So it's really deep bottom, poor soil. And it turns out there's some views that they'd like to protect. So there's limited boat traffic, meaning there is boat traffic, but it's not container ships or cruise ships that are going underneath there. So, and the lake is controlled in its height. So it turns out a suspension bridge doesn't work well because there's no good place to put the pilings. Really don't want the visualization of this, what could be a beautiful suspension bridge blocking the views. So we have a new floating bridge, right? They replaced the old floating bridge. And the point is that there is all these are good designs. It really depends on the requirements, and then is the design actually flushed out all the way? And that has a lot to do with how we've come to where we're at with the artifact spec. And that was about what are the requirements? Now, we didn't set out to define references. We were building Notary v2, and we were trying to figure out how do we accomplish the goals. And a lot of it was based on what did we learn from Notary v1. It wasn't v1 was a really poorly intended approach. There was some things about it that we wanted to fix. And one of which was we wanted to promote things within and across registries. For anybody that's used Docker Content Trust and Notary v1, if you sign an image in repo 1 and registry 1, you can't even copy that content to repo 2 in the same registry without having to re-sign it. The whole point of signing is I can move things and know where it's still the same identity of where it came from. Not the only point, but a main piece of it. As we were going through this, and this actually took us a couple of months, we don't have the whole list of people there, but Brandon was part of this original conversation. It took us a couple of months to realize we did not want to change the tag or the digest. Kind of sounds obvious now, but at the time, there was a lot of debates, like why can't we update the tag with something new? Notary v1 did it. Was that a bad thing? Turns out it was. We wanted to make sure that all the Helm charts, all the kube deploy files, all the Docker lock things that turned a tag into a digest, that those flows didn't change. All we were doing was adding the ability to check a signature on it. We wanted offline signature creation. This one had a little bit to do with how we create manifests, and we couldn't just rely on when it's being pushed, the manifest being created on the fly. It actually has to get created offline. Because the idea is you want to build the image, build the SBOM, sign them all, validate them, and then from this isolated machine that can't talk to anything, then you could send them to a registry out of the environment. And by the way, anybody has a question, we have time. We purposely blocked 90 minutes because we really wanted this one to be the chance we have a chance to talk about this in detail. And I can't see if somebody I don't know if I'll see if somebody raises their hand, so can somebody just keep an eye on that? We wanted multiple signatures per artifact. We wanted to be able to say that the net monitor image by this small software company, they can sign it. It gets promoted from their small company to something like Docker Hub, where people would trust content from Docker Hub if it's certified content. So it would be signed with the Wabbit Networks key and a Docker Hub certified content key. Now, the stuff that's on Docker Hub that's not certified, that's either not signed or it's signed with a different key that just says, yeah, it came from Docker Hub, but there's no guarantee of the content. The point is that we wanted to be able to associate multiple signatures, because when I then promote it into my environment, we use Acme Rockets as the small customer, there's another key that gets put on it that says I imported into the Acme Rockets environment. So now I have at least 3 keys on it. And what was well, I'll get into the side effects of it, or the benefits of it. We also use the terms native persistence. We didn't want to make the registry know about signatures. We saw basically from the artifacts approach that if we can keep things generalized, that there's probably other things that might be interesting to store in a registry that are enhancements to something. So we're already kind of building on this idea. We wanted to add something to it because we already went through the don't change the tags and digests. So how do we keep that generalization going? We needed to support air-gapped networks, and air-gapped networks are not just submarines and oil platforms. Pretty much every customer in public clouds wants their private environment. They want private IPs. They want to limit what you could connect to, both egress and ingress. How do we make sure that we support that concept that the signatures are not somewhere else, they're with the content? So these kind of, this story is not really meant to be or anything around Notary V2. The point is we were going through that path, and that's how we were coming up with these requirements that we wanted to make generalized. So we wanted to be able to, like I said, content promote stuff to secured environments. The Wabbit Network stuff, I've got an image, an SBOM, I might have GPL source. All of those are signed, little blue signatures. It gets promoted to Docker Hub. There's some additional signatures put on it. It gets promoted into the Acme Rockets environment. It's air-gapped. That's what that double line is representing. And then there's a third key put on it. In fact, inside the Acme environment, they might create a deploy script. Don't even care what technology it is. But it's signed with an Acme Rockets signature so that now inside of Acme, they don't need to look at any of the other ones. Like when you go into the airport, after you've passed through TSA, they don't look at your driver's license or your passport anymore. They look at that little stamp that's on your boarding pass. So we wanted to make sure inside of those environments, you don't need to look at any of the other keys. And again, the point here is that what we recognized is we needed to be able to add associations to something that was in the registry that we could promote across. So we kind of came away with these principles. Multiples exist, and we're really trying to avoid having to build yet another storage service. It's not that the registry is complete by any means. It's, do you really want to build, and I had a slide, I actually don't think I have it in this deck, of the eye chart of list of features that all of our registries have to implement. And none of them are exciting things per se. VNets, customer managed keys, availability zones, geo-replication, resilience, blah, blah, blah. That's not something somebody's trying to build a new service for. So can we do this in a way that we can add to the infrastructure that's there so that somebody's trying to build their thing, they don't need to build the storage service for their thing. So here we've got the references are persisted alongside, and you're starting to see some of the terminology come in, the thing that they're associating with, container image, a WASM, a Helm chart, whatever. So we want to be able to solve this discovery problem because inside of that air-gapped environment, I can't get to Docker Hub. It's explicitly blocked. So I want that signature, the SBOM, security scan results, things we haven't yet thought of yet to be in there. They're also separable. So I call this the Trojan horse attack, where I don't want to download the image to pull a layer of the signature. Aside from the fact that if you put it in as one of the layers, the digest changed, but I want to be able to say, just like you stand at the passport line and you hand your passport through the window, you don't go through. You get your passport through, and if they approve you, then you go through. take a look at the SBOM, take a look at the signature, take a look at whatever the reference type is that you want to use. And only if that's approved do you actually download the container image, the WASM, the Helm chart, whatever. And then the last one is the same thing as the digest mustn't change. So then we kind of came back to, all right, what does this mean for registries? What is it that we want in a registry? And I've actually purposely, that white space on the graph on the right is purposely removed because at this point, that's not important. The idea is we want to be able to push something, push a reference type to something that's already in the registry, meaning the things that are already there today. And we looked at many to many, we looked at one to many to one, and what we landed on was there's one thing that we put in the registry, like a Helm chart, a container image, whatever, and I could have multiple references. I could have multiple signatures, multiple SBOMs, multiple signatures on SBOMs. So if you notice, there's a graph there. And what you're seeing is also this reverse index thing that we've been talking quite a bit about. So a manifest for a container image has a downward, I refer to downward reference to the config, which is persisted as a blob, and n number of layers. This manifest knows about that. When I push this netmonitor image, it didn't know about any signatures. It certainly doesn't know about the new signatures I might add to it. Because if it does, well, by definition, the manifest then is changed, the digest changes, my ID changes. So we needed a way to send a reverse thing to it. So in this case, I'm pushing a signature, which persists the actual signature as a blob, and it has a new property that is referenced back up to that container image. And then, of course, it just continues, and while the first thing is actually the OCI image, if this SBOM is persisted as an artifact manifest, for instance, the signature, which is an artifact manifest, it can point to it. So basically, we wanted to make sure that you can sign anything or put an SBOM in anything that made sense. So you don't need to, what I didn't put in here is we didn't want to have to touch or risk anything to do with the container runtime environment. There's literally no change to the container image stack or runtimes or anything. All of this is completely transparent to it. So as part of the one-to-many, I was trying to remember where I was going with that. We wanted to hide all this metadata. And I'll show a slide in this in a second, but basically we really didn't want the fact that there is a signature in SBOM or things that we haven't thought about to pollute the APIs and the UIs that customers are using today. How do we surface this information in a way that can be additive and not, be acknowledged and additive, but not pollute the existing APIs? Again, we didn't want to break, and I'm doing the air quotes on break, the existing experiences. Now, the important part of that arrow is this discover of references. Because what the customer is trying to do when they deploy that netmonitor image, they're not looking for a signature. All their references are netmonitor :v1 or netmonitor, at SHA-256, blah, blah, blah. That's what their references are. What we want to be able to say is that, and that's the value that travels through the ecosystem for their end-to-end relation, the end-to-end workflows. So when that kube deploy happens in an OPA, or whatever you want to put, some kind of validation there, the information that passed through was the netmonitor and the digest or the tag. So now we want to be able to go back to the registry and say, hey, what references do you have for this thing that I'm trying to deploy? We didn't want to have to send new information through that pipe. We want to say, look, it's actually a reverse index. The registry now knows that these three things, or actually it's two things to be fair, the SBOM and the signature were added to the image. But the registry needs to know about that somehow so we can pull it out. And that's this Discover API. And because we recognize there probably won't be tens of thousands of references, there may be enough that I don't want to get them all at one shot. We wanted to do some filtering on it. So I want to know which is the SBOM, or sorry, which of the references are an SBOM? Which of them are a signature A versus signature B? Or actually, a notary signature versus a co-signed signature. And then if it is one of those signatures, because I might have 3 Acme Rocket signatures on it, sorry, I have 3 notary signatures on it, which one is the Acme one? Because that's the only one I care about. I shouldn't have to go back to the registry and know, I shouldn't have to get a whole round trip and get the blob back just to find out, oh, that's not the signature I was looking for. Now, this was the other interesting challenge. If we can know that something's an SBOM versus an artifact type, an SBOM versus a signature, and signature type 1 versus signature type 2, how do I, and that's a generalized concept. The idea that I can store things in a registry and there's different types, like there's container images, there's signatures, there's SBOMs, and there's different companies doing, or different projects doing different SBOMs. How can I say within that artifact type, how do I have a different differentiation, a different pivot? And we don't want the registries to know about any of these specialized types. So we said, all right, this one we think we can use annotations for. So the signatures might put an annotation for the CNAME or subject or something that says, this is the Acme Rocket signature. You can't trust this yet, but you can at least use it as a filter. So don't bother pulling the other 3 signatures down just to find out those were never the ones you wanted. There's an annotation there that says, yep, that's the one. And now the notary client can go figure out what it needs to do to go validate that. So we're trying to figure out how do we bubble up generalized concepts that can be used that aren't specific to any one technology. And then the pull turns out we actually didn't need to do anything on pull. Registries already have pull APIs that go by digests. All we had to do was make sure that the clients can figure out what is the digest to pull through that discovery API. And then the last one that's been the fun conversation is lifecycle management. If any registry that's been running for a while has a lot of content in it, and whether you're free and paying it yourself or customers are paying it, they really don't like the idea of endless storage. And it's not just the cost of storage that goes into it. Pretty much, it's not a secret. Every registry that's started probably didn't deal with deletion up front. Some of them I know are just implementing it now. For the first year or two, ACR, we did delete it from the UI and the APIs. The content looked like it was gone, but it was actually still there. We took it out of the indexes. And we finally had a customer says, look, I know I deleted it, it's not there, but did you really delete it? Like, what do you mean? You're not paying for it. It's not, it's not in your quota. It's not, you can't pull it. Like, yeah, but there's legal reasons we need to make sure it's actually gone. So we've all had to go implement that work. Likewise, customers that are keeping content, they didn't delete it yet. It's because they don't know how to manage all of what was deployed versus what was just built and pushed. So and again, the problem here is now you start doing security scans of what's in the registry. There's anything that's a couple of weeks old probably has some kind of vulnerability into it because just the way things come around. How do you know, if I want to, let me rephrase that. I need to be able to go delete stuff because if it's not used, I am storing vulnerable content in my registry that's not being used, but it's still stored there. I need a way to get it out. And I need all of the little pieces of this metadata to have a way to go with it as well. So if we're starting to store these references, we needed to recognize that the only way to really do this in a complete way is to make sure that registries can track these things as a graph and have a way to delete not just the big blob container images, we joked about the size of ML images before, but all these little objects add up. They're just a bunch of zombied objects if they're not actually tracked and have a way to customers to delete them. So this was the other piece where I was talking about like what should be seen. So if I've got a repo with a list of tags, and here I've just got a bunch of unique, build numbers. Well, if I'm listing tags and now I've got to start assigning like signature or signature for Acme Rockets and signature for Wabbit networks, or what is that other thing? Well, there's a signature for that other thing, and there's a, and then because there's multiple signatures, this starts to get pretty messy. And I'm not even including digest in it. This is just, I've played around with the idea that I could have tags. Well, based on the artifact type, in artifact, the stuff we do today, I can use the manifest config.media tag, fine. I can actually put a glyph on it and identify that these are signatures. It's still pretty noisy. That's not the way a customer wants to see this information. What they really want to know is, I'm thinking about a container image. Yeah, it's interesting to know it's signed. Let's change that as a pivot of information that could be on that image, on that CNAV, on that Helm chart, on that WASM. And maybe I can store SBOMs, or maybe I can store metadata, or maybe I can store other things I haven't thought about yet. But the idea is I have enough information, the way this stuff is represented in the registry and in the manifest and all the APIs as this goes back and forth, that I can do something like this. So that's part of that. So I actually don't remember why I have Ginger again. So I'll pause there for a second and give folks a chance to ask questions. There's got to be some questions, or I don't know why we're doing
Jason
this.
has his hand up.
Oh, thank you. Go ahead, Jason.
Okay, so the issue of you can hear me, right? Okay. The issue of the tag pollution, is that something we could solve by improving the tag list API to have filtering in the tag list API?
Hope so.
Okay.
Yeah. So,
Great.
but the thing is, what are you going to pivot? What are you going to do? So I think your first question is, can we change the APIs? I sure as hell hope so. So if there were a couple of months ago, I started a conversation of like, well, what do we want as parameters to these various list APIs, search APIs, whatever you want to call them.
Mm-hmm.
And that did not go as constructively as I had hoped. So I think those are the kind of things that we're trying to gather the requirements to figure out, what should we do? So, do you want to just search a tag with a regex? Like, is that really, sure, you could. Is that really all that helpful? What if I have a way to know that this tag is a Helm chart? It is a signature. So that's the kind of things that we want to be able to do. Or it is a reference to something. Should I even have to tag something? So I actually agree with you. I do want to pivot on tags, a tag listing, but I don't want everything to be tagged. We don't tag layers, right? They're a detail of a manifest. Is signatures something that really needs to surface as a first class the same way as the container image? Or is it a special type of metadata that I want to be able to pivot on? So great question. So
I think Josh also has his hand.
Oh yeah, yeah. I can't see who's got hands up. I
don't know the proper way. I put my hand in here, but
I actually opened it up. So Josh, go ahead.
Like, I'm confused in some way by the presentation of this, because you're like, what is the main takeaway the way that we're referencing between different types of content, or is there something special or prescriptive about the signature and SBOM piece, or is that just like, I'm just confused why signatures and SBOMs are like brought up so much, because I feel like you're talking more about how these things are connected, and you might as well say like arbitrary types of content versus signatures, because it confuses me what I'm like taking away from like the proposal.
What I'm trying, and if this doesn't answer the question, then tell me. What I was trying to do is not explain the destination we wound up, but the journey, to understand how we came across these scenarios. Like we obviously started out with trying to sign content. As we were going down that path, we recognized there was some, well, one, as we're signing content, we wanted to try to avoid the mistakes of V1, Notary V1, with the,
this is like a solution that has come up by trying to address a Notary V2. And so all of
this was
the takeaway from artifact spec is because of the requirements of
the requirements and the journey. And we did not want it special. We wanted to have Notary be Notary, and we wanted to have the things that were common to a registry be separable. So like when we started this, we weren't thinking about SBOMs. I spent a year arguing with the Azure Security Center that I did not want to store scan results in the registry because I didn't want them querying the registry just to get the scan. I was like, you should have your own database. You should do that on your side. As the more we got through this, we realized that the pattern that we were going to do it for signatures turns out it was much more generally applicable to other scenarios. So like we didn't start out trying to solve SBOMs. In fact, we don't actually have this group that I'm working on, we don't actively do any SBOM work. We're doing signatures and we're doing the registry infrastructure.
You're just saying conceptually, this is a way that you would address.
Yeah.
Got it.
Did that help?
Yeah, I just didn't know if you're proposing like, I felt like it was a boiling of the ocean, and you're more proposing that we can connect these things, and SBOM and signatures just.
They're a fallout of a benefit of the generalized design that we've taken. So, yeah. I don't see anybody else with their hand raised, so I'm going to collapse this actually so I can.
We are good to go.
Thank you, Amy.
Sure.
So the idea is that I can push an image, I could then sign the image, and then I can do an SBOM, and I could then sign the SBOM. And the idea is all of this stuff can get persisted in the registry. And now you are starting to see some of the details of how we went about it. But I'm actually trying to save the implementation details here for the moment, because I know we'll have a lot of discussion. I really wanted to try to ground it in why we're going around, why we came to this conclusion and the approaches. And part of it is the versioning, but a lot of it is to do, this was the scenarios we're trying to enable. So I'm going to figure out how to do this. Can you guys still hear me?
Yeah, you're fine. Keep going. Okay. I will shout if you wander off.
Thank you. All right, so this is, I wanted to, without getting into the details, I wanted to kind of show the experience where we landed. And of course, now I have to find out where my little demo script is. All right, so what I've got here, and I'm just running the docs that we've put in the artifact spec. So anybody can follow along. So I'm just running an instance of Docker distribution. So for us to validate this, we didn't want to just start and end with a spec. We've been working on this for a long time, getting a lot of feedback. We've been validating it by building this, not in Azure, but in a vendor neutral way. You don't need to run anything with Azure to do this. Not only is it nice that others can use this outside of Azure, it turns out it's easier for us. I don't need to do a 50 region, 5 cloud deployment just to get a change, right? I can just do this by building and pushing it to Docker Hub, or where I think GitHub is, I think, where we push to the image. So I'm running that, and then I'm just going to I'll do the build of the image. Oh, sorry, wait. Docker build. Did I not start? I thought I had this running already, sorry, hold on a second. Well, that's not helpful. Okay, so let me go back, and now we'll do our Docker build, which actually still doesn't make sense. Invalid argument now. So what happens when you go to lunch before demo? Oh, I see. Something happened with, I got an extra symbol here. Really? Localhost. Oh, the port's missing. Oh, I see what happened. Hold on a second.
Always do the demo live. Hooray.
Yeah, really. Okay. So let me paste this again, because I think I was missing. And we'll start this up again. Okay, that looks better. All right, so let's do that build again. Nothing special here. It's just successfully tagged. And then we're going to push it to that local registry. And we'll talk about offline later. It's the point here is I'm just trying to not add too many new concepts. So I simply have the net monitor image in the local registry. I want to sign it, or I want to, in this case, I want to generate an SBOM. I don't want to get in any details of whose SBOM it is, so we're going to generate a simple SBOM that says it's good. I want to push it to the registry. Now, I cheated here because I didn't want to have to do all kinds of curls and posts and everything. I'm just using ORAS that pushes to a repo. It pushes a type, it gives it an artifact type of SBOM example. And it's linking to, it sets the subject property to the image. This is the relationship that gets established. And then just take the JSON object and persist it as a blob, right? I think everybody here knows the magic that we do there. Well, knows the push APIs generally, but the point is there's two extra pieces here. One, that we're establishing the relationship, and notice there is no tag on the thing that I'm pushing. I'm just giving it the registry and the repo. There's no tag. So it pushes as a digest, but it does say that this is an SBOM example for a type, and it has the reference. And just for fun, because I want to be able to show filtering later, we'll push a signature which is signed by, I think I had a Jane Doe, I don't remember what I had. I think it just say it's signed at this point. So I'm just going to push this again, and it's no different than I just did with the SBOM. It's pushing to that same registry repo. There's no tag. It generates the digest and pushes it. It says this is a signature example, but it's also establishing a relationship to the same image. Take the signature JSON and send it up. In this case, it's not even being tarred. It just sends it up as a JSON file, just a blob. Now, this was important. We wanted to make sure that we are keeping that repo clean. So if I look at the tag listing on that net monitor image, there is just the V1 tag. The information's there, it's just not surfaced in the tag listing. So as people start using the signatures or SBOMs or whatever it is they're storing, because we don't care at this level, all of their existing experiences are maintained. We didn't break anything. We have to go back, and now they have to do something around their tag listing, to your point, Jason. So now I want to get the references out. So I want to be able to say, hey, netmonitor image v1, what is referencing you? And of course, the netmonitor v1 manifest doesn't have anything in it that says what's referencing it, because those were added after. It needs to be able, the registry needs to know how to do that reverse index and pull it up. Now the refers API, which we'll spend more time talking about in a minute, it takes a digest. It doesn't take a tag by intention. So I first have to get the digest for a tag. And we happen to use the ORAS Discover API to get that digest. And then I can curl the refers API back out. So what we're saying here is, hey, registry, hanging off this place, which there's a discussion we've got going where we want to be able to have an extensibility API. I think it's PR 111 or whatever. On the netmonitor namespace, use the manifests, pass it a digest for that manifest, and then there's a refers API hanging off of it. And it returns a JSON object that says, here are the references to the netmonitor digest. And if we look close, we'll see that not only is it a digest, but there is an artifact type property in there, because if it was just digest, I wouldn't know which one's the SBOM, which one's the signature. And of course, this would say signature type A. Sorry, that sounds more abstract. This could say cosigned, it could say notary, it could say Josh's signature format. So I'm staring across the table at Josh. There's another annotation that would show up here that would say when it's signed, that it could actually set an annotation that says, this is the Wabbit Network's signature, which then the client would verify, but at least it knows to filter on it. And if I use this, not only can I get the reverse index on it, if I look at this query, there's a parameter on it that says artifact type SBOM example. So the registry still knows about two, but the API has an option that says registries can or may, whatever, may implement filtering. So now I can get back just the filtered list of that type. And now you can, since we don't want to always have to curl, we can actually use things like the ORAS API to do a discover with an output of tree. I can do it with the filtering or without the filtering. So notice here, I can now see them both, and they're hierarchied by the type. And then lastly, if I want to pull it back out, it's the same pull APIs. We didn't have to change anything. The only thing I'm doing here is I'm first, I've got a little nested one, is first go discover the artifact type for that filter by artifact type for SBOM, get the digest out of it, and then it's just doing an ORAS pull of that digest. So now I've got that file back out. So now I've round tripped it through the registry, and all of those requirements that we've talked about is how we want to be able to push content in, understand it's different, not break the existing experiences that customers have. Registries do opt in to this behavior. There's no question that this is an opt-in because we think it was important to opt in so we don't break all the experiences. And then you get a full experience back round trip. I'll do this one more slide animation, then I'll pause again. So today, with all the registries, you can do a Docker pull, Docker tag, Docker push. And I can get that across a whole registry from public to private, whatever. This whole pattern that we're doing, because I know a lot of times this comes up as, why don't I just do this with the client CLI? That's what NPM and other package managers do. That's true. But other package managers aren't trying to store all kinds of types. And all those types of types should have their own CLIs. The Helm has its one. The Helm has its CLI. The WASM has its CLI. The Singularity has its own CLI. All of these things should have their own CLIs to have their own experiences that they can define. Just like the applications I use on my laptop, they all have different programs. I can use the Office apps to write and save various Office documents. I can use VS Code to save things. I can use something else, Golang files, whatever. But I don't need the Office APIs to copy stuff. I go use the file system APIs. The file system APIs don't know or care that they're Office documents or Golang files or whatever. It just knows how to copy things across. So that's what we wanted to do here, is we wanted to be able to say, hey, there's some OCI registry client, copy the content from Docker.io to some registry, and if I don't specify different, copy the whole graph. There's nothing in that generic CLI that knows anything about any of the types. It just knows how to read the graph and copy them across. And now I can do things like include, exclude, because I might not want certain things to copy across. And I think that was, and because when I copied it across, it went into that, it's some kind of data diode that I can get the information into that target registry. I can now validate the signatures and SBOMs and signatures on the SBOMs and the security scan results. And another thing that we haven't thought of yet, or the community hasn't thought of yet, that they can assign as a graph and get copied into that registry. So before we get into the whole, here's how we wrote the specs and everything, I really just want to kind of set the stage of what was the experiences that we were shooting for, why, how did they surface in different places from not just APIs and manifest APIs or manifests or Docker push and Docker pull, but the browsable experiences that customers have on their registries, or the tag listing or other APIs that they have. How do we not physically break and an experience break those? They basically can opt in and get them as they want them. So I'll stop there. And I realized I wasn't holding the mic. I hope you guys were able to hear me okay.
Yep, you're mostly fine. I will hold for questions. All right, seeing none, no hands are being actively raised, but that doesn't mean that there isn't questions. So,
yeah, is there anything in? if there's no questions, then I'm not sure we could give everybody another session. The whole point of this was to have this conversation of the things we've been ragely debating for more than a year now.
I think most of the people that would have had questions have probably seen this over the past year.
Michael Brown, passing to you.
I can ask a question. I'm curious, like sort of following up on what we were talking about this morning, with the question of, I think we've been iterating on this as a separate manifest type, and I think the plans would be for at least some of us to launch with this as a experimental or other manifest type. But what are people's thoughts on sort of the eventual direction? Is this something that could be merged into image spec v1.1? Does this actually warrant its own media type and separate manifest type? And sort of how do we kind of like take this fork and merge it back or incorporate it back into the future direction of OCI?
Let me just do one thing and split that conversation of before because there's a hint of a bunch of implementation details there. How do people feel about the scenario? Like, is this something we want to support through? I mean, this is largely distribution. We want to be able to support the container image formats with these capabilities, but the point is this is really focused on, do we, as this OCI group and the people out that are slightly outside of it that are interested, are these the scenarios that we want to support? Because if we don't, then the implementation doesn't matter.
Not generally a kind of place where we do voting, but yeah, sure, I'm definitely interested. If that helps. I think we obviously always wanted to do metadata. We just didn't get to it. So we did annotations instead temporarily as a workaround in many places, as you've seen, even with digest, we can do annotations. But we recognize that that's not a programmatic, solution. Aw.
Yeah, and the annotations is an interesting one too. I'm sure if the baby wanted to vote in here. It's the interesting thing here is it's not that the annotations that I knew when I built the image is one set of annotations. What happens when I have some annotations that I want to add after I've pushed and promoted that image across different environments? Without
in what process? You probably haven't seen it. There's been some discussion around, what could we do with the tags API in the Slack. I don't know if anybody that's been chatting on that wants to bring it up, but I mean, it is probably not a good place to discuss alternative implementations, but I think the answer would be yes. Pretty much everybody wants to do these extension points, Steve, at least as near as I can tell.
So your point is without getting into the implementation details, what you're saying is we not only do we want to support annotations on the originals, we want to be able to support additional annotations that don't change the digest of the original thing.
Yeah, and I think we'd rather have, fields like reference where that's, applicable, so that you can attach refers. In some sense, the tags were refers. And if we had there was one suggestion, was it John or somebody suggested using another well-known tag name. So instead of :latest, maybe :metadata would give you a root blob, for example, of some other metadata that's been extended. In other words, there's ways to do this.
Yeah, no, I'm trying to avoid the ways. I'm trying to just, I want to get past the first part is this an interesting scenario? Because in some conversations, they're like, we don't want to do this in registry. This is something you should go off and build in a product. So we could have built this as a product. I felt that that was the wrong thing to do. That's why I'm kind of just before.
No, I think right now, I think the key thing to catch what was mentioned earlier is that, we don't need to agree whether or not these are important things, because they are. from a spec perspective, it was more, I think the general question more is, can we do it in a generic enough way as an API to support these extension points without getting in the way, right? As a spec group. Or at least that was one of the questions and points made earlier.
Nisha, you're next.
If I can unmute my mic. I may have been a little late to the game, or like this conversation. It's been happening for a year now, and I've only just now, maybe only lately, have I understood kind of some of the nuances, but not really. I wonder if someone can explain why the current state of the specification does not allow for all of these various features. Steve, you can.
Yeah, there's two parts to it. One, I definitely want to spend. This is why, again, why we have so much time is to have all those conversations. Jason, was yours going down more the technical aspect, or was it more of the scenario first?
To answer Nisha's question, there's nothing in the spec, as I understand it, that says a registry couldn't implement this exactly as described with image spec and distribution spec. The problem is that the referrers API would be not governed by the spec. Any registry can implement the referrers API if they want to. Anybody can today push references if they want to. The problem is that would not be specified, and therefore it's not portable across registries unless registries agree. And if registries agree, then it should be in the spec.
Right. I mean, every registry implements some kind of eventing model. Every one of them is different. Every registry's got some kind of way of getting a list of repos out. Most of them are different. So the point here is, can we define it? And I had a couple of slides I was going to go down. Why do we build specs? And it was, it shows a path of a muddy road. It's like, okay, clearly cars are going down the way. Maybe we should pave it. Well, once you start paving it, there's people walking on the side of the road getting hit by the road. It's probably an idea for some sidewalks and some bicycle paths and so forth. So we want to find the established patterns, build them in a spec so that they can be implemented across competitors and collaborators in a way that the content can move. I mean, quite frankly, in addition to just, I'd rather be doing something in the community as a whole and kind of up-leveling the whole ecosystem, because I think these are not the places, the registries are not the differentiators in the cloud. And all of our customers have some interaction with another cloud or another project. So and we've seen these done in individual products, and they're not as successful because they're not capable across other registries. We have people running JFrog inside of Azure. We have people running Harbor inside of Azure. We have on-prem registries that are trying to connect to Azure. And then we have MCR content, the Microsoft content that we ship, that when we sign, we want to make sure that somebody pulls it into their on-prem registry or a competitor's, I'll air quote, a competitor's cloud registry, that signature can flow with it. So we think it's really important to do this as a standard and do it in a way that can be implemented by fierce competitors, in addition to people that just do want to get it done. So that's the approach. Yeah, go ahead, Jason.
Sorry, I don't mean to interrupt, but I've only got about 5 minutes before I need to pick up my daughter from kindergarten. I feel like half of Michael's question got dropped in the answer to his question, which was can we, and if so, how iterate image spec toward what you're describing as a use case? I think we generally agree the use case is valid, but one approach is to invent a new manifest type, which is certainly easier to go alone. And the other is to iterate image spec, which is to go farther together, to borrow a thing I saw embroidered on a pillow one time. That was my main drive in asking that as the morning session, was like, can we update image spec? Do we have the will to overcome the challenges? I don't have an answer to that, obviously, but that is like the crux of the question to me. And thank you, Michael, for asking it. And I wanted to make sure we didn't lose
Yeah,
it.
no, I definitely didn't want to lose Michael's question. I just wanted to tease the question apart from the scenario to the.
Yeah, I think the second part of the question is the real important part of the question.
Agreed.
And I wanted to get back to it because I think it's important.
Totally agree. So your question, and I'm sorry you have to cut off, but if you have to leave, but we started this 3 years ago, whatever it was, when we started the artifacts spec, the artifacts work, and we get to the whole spec conversation, the artifacts work, that we did want to put it on the image spec. We asked for a property so that we can differentiate. That went back and forth for months on whether we can do it. We landed on using the manifest.config.media type because there was no willingness to have any kind of additional property added. Even though we now talk about how it's totally valid to add another property and registries must accept them and clients must accept them, it was not tolerable to be accepted. So
do you have any notes, contemporaneous notes or recordings of those conversations? I'd be curious to understand why there wasn't an appetite for that at that time, because I think that's our only possible future for image spec ever changing. And if there's precedent for a decision that says that that's impossible, then I think that answers the question, one way or another.
Well, I don't think the answer was a good one per se, but those are all captured, and I can go back and dig. They're in issues and PRs on both the image.
I'd love to see that. That sort of history is exactly the thing I like as a relative OCI noob, and it would be really helpful, I think, for other people joining the conversation, in 2021 instead of 2018.
Yeah. So, and I think, to be fair, a lot of them were like, we don't even know if this is a thing. So we're not really going to spend a lot of effort arguing over whether you can, should, or would. It was, we don't really know if this is a real thing. So this is the best we can do at the time. So it's just a matter of at a certain point, you just stop. It isn't worth taking any further, so that we were able to graph it onto an existing property. So there's definitely history there. I just don't know if we have a different conversation now because there is a lot of the additional types that are not container images stored in registry. In fact, I'd be curious how many OCI manifests compared to most of the Docker images are built with a Docker manifest. How many OCI manifests are actually artifacts as opposed to container images?
Yeah, I think it's a good point that not only do we have, the world is different than the last time this question was asked. There's more of an appetite to store non-container image things. There's more of I think we know that we want SBOMs and signatures to be linked to things somehow. So if the problem before was that there wasn't an appetite for it, I think that has changed in the last 3 years, and it's worth revisiting whether we need a whole new manifest type or if we can iterate. I don't want to filibuster this anymore, and I got to go get a kid. So
yeah, sorry.
I'll watch this recording later, and good luck.
Okay, so if there's more questions on kind of the scenario-based scenario, we can switch over to more of the technical conversations.
Seems reasonable, and your time check has got roughly half an hour.
Yeah, thank you. So if we go, let me just hide some of this stuff here. If we go into, let me remember where we refactored some of this. Let's see. So if we compare the two, so there was a couple of pieces around what we felt we needed as part of the scenario. One of which we felt it was pretty important that we had a way to differentiate types. Not by a tag pattern, not by even an annotation. We really felt it was important to have a first-class property that really surfaced what this thing is. In the original OCI artifacts work, that was the manifest config.media type. It was great, it got us unblocked, but we have there's been bugs in registries because technically the config object is required. So we're saying put a media type on an object that doesn't actually need to exist. So the bug tends to be there's a 0-sized blob that gets pushed to registries. So that's been partly problematic. It also means that you can't actually use the same media config object, config type, across something like a container image and a WASM, because we're using that media type to say this is a WASM versus a container image. So that's how we wound up with the artifact type property as a first-class object on it. The more obvious one is the subject, what we now call the subject property. It's had like 6 different names along the ways, but now we're pretty much stabilized on the subject being it. And that was the other one that says, all right, this is an optional property that when I push this thing to a registry, and I'm not getting into the fact that we're calling it an artifact manifest. I'm just saying this is a property that we want to put. The big thing that we wanted to say is it's not just on a descriptor or on a blob. It's actually a manifest object. Because part of that lifecycle requirement said that we wanted to be able to think of these signatures, which could have 1 or more blobs, right? In fact, I think Helm now is 2 layers. So they have their provenance, whatever. But the point is that we never wanted to limit this to just 1 file or 1 tar that can get put to the registry. The container image format or the distribution and the whole ecosystem has this awesome capability that I can have multiple collections of files. And they have this great deduping feature. So we wanted to be able to say this thing, because when we look at things that are in a registry, the blob is the implementation detail. The manifest is what really is saying, this is a container image, this is a WASM, this is a Helm chart. And the blob is just an implementation detail. It's an important one, but it's not the thing you reason over. So we put the subject property on the manifest. This signature is represented by a manifest and can say it has an option to say, I refer to this other thing through the subject property. So that was piece 1. And then, of course, to get the information out is the refers API, but then we're getting more into the APIs to get the data out, and I think there's less contention there than there is on the image spec. So that's those 2 properties. Then when the further we got along, we just had so much pushback on making any changes to the image spec that would risk possibly breaking any of the container runtime formats. So all right, the distribution spec allows for new manifests. Why don't we go down that path? So when we did that, we were able to do things like the config object is now optional. In fact, we even did a little better optimization that there actually isn't a config property. The config just gets put in one of the blobs with its own media type. And blobs are optional. The blobs collection, which was layers, by the spec of it, it's not even ordinal. The Helm chart, they use 2 layers. There's nothing ordinal about them. They know what layer is which because there's a media type on it that differentiates them. So that was a minor detail. This is like the cleanup work that we can do. What was the other piece? Oh, then there's the larger one that we really wanted to be able to start refactoring how these specs are interacting. This is what Vincent was talking about this morning. The container image runtime, I use the Helm and WASM community. The Helm and WASM community doing all kinds of interesting things on those specs. They take that generic spec and say, this is how they're going to use that generic spec for their use. What we wanted to be able to do is decouple what the container image format is trying to do for its uniqueness from the generic manifest. So by having the manifest say, look, we can support all these scenarios, then for instance, in the container image, and I have an example of how the container image could be put in this, and I hate doing this one because this always suggests that the container image should move to this. I'm not. I'm just showing what let me see if this is the right one. Yeah. If you were to take the container image format today and wanted to store it in this new manifest, all I'm trying to show is here, if you pivoted on the media type, there is no config property, but if I split the collection on the media type, here's your config object. It's just in the blobs collection. And then here's your ordinal layers for the container image format. But it's not this manifest isn't ordinal. It's just saying that when you put a container image in it, you're saying it's ordinal. Just like when the Helm chart uses the manifest it uses today, details are important. They've decided how they want to use the manifest. So what happened was if we can't change the image spec and it's in an org that is not really focused on storing generic objects, and I say org, a group, whatever you want to call that boundary, we wanted to free up the image spec maintainers to focus on the container image and let the distribution focus on what it's trying to do, store for all types. So all of those pieces combined is how we wound up, where was I trying to go here? With, get back to it. I think, wait, it actually wasn't here. Why there's differences. And then because there was so much questions, I was trying to answer it with a bunch of details of, well, why did we have a new manifest? So I took a long time and wrote this up and took a lot of feedback. And I know people are busy, and then this is the wall of text answer. So there's a lot of details in here. I'm happy to walk through those, but Jason, Jason's not here. To Jason's original point, not only was there no interest in making potential breaking changes, or not even potential breaking changes by adding even properties to the image spec, it wasn't the image spec maintainer's charter to solve this problem. So we wanted to do the refactoring. Does anybody want to, Michael, you want to pick up where Jason kind of left off on that?
Yeah. So, I mean, I think that we definitely have, I would say like some of these are big deals, right? Like config being required just probably doesn't make sense, or maybe config needing to have a blob doesn't make sense. The layers being required and ordinal doesn't seem like something that artifacts should care about. Like it just doesn't matter. Clients can consume them as not ordinal lists just fine. I believe.
Technically, you're right. The Helm chart doesn't pull it down and care about the layer. So if somebody maintains the ordinal, nobody,
like we're in a,
it doesn't care. But if it's
we're in a content addressable world here, right? So everything is ordinal, whether we like it or not, because otherwise the digest changes.
Yeah, I guess that's true.
So like, there's no way to really change that constraint. It's if you want the digest to stay the same, you can't change any of the formatting or ordering of the manifest. But I guess I still am hoping, even with this work going on in this repo, that we are able to merge or adapt into the image spec. And so I think, with the summit and as we sort of start to finalize on some of the details of our proposal, I think it's like a really good time to sort of ask for image spec maintainers to give input and see if this is something that the image spec could or should or is willing to accommodate, and if not, whether OCI needs to spin up a third or fourth spec for non-image things that are stored and handled by OCI clients.
So Brandon, before I go to them, just one of just two details. One is the layers, while we don't care if it's ordered or not in any of these types, the manifest keeps it, to Philip's point or whoever mentioned it. The fact that it's required winds up being a constraint also. Like here's an example, and we started getting a little sidetracked on it, so I did close it. But to Mike's question around, how do we add additional metadata? This was one of the things we started playing with, is I can actually add another ref type and push it to the registry and say, this thing is adding to the container image netmonitor v1, and I've added 2 annotations to it. And because the layers or blobs is not required, this is a completely valid manifest push. So
I think for that though, I would go back to the sort of overarching principles of what we're trying to do here. Like there so far, at least to my knowledge, have been no use cases that people are asking for that would require us to support something like this.
Well, this is one of the ways we were going to do additional metadata. Josh, can you hand Sargon the? Sorry, Brandon, Sargon hasn't asked a question, so I'm going to let him interject you. No, we heard you. It worked.
It worked. Okay. If annotations can be added post hoc, doesn't that kind of cause problems with the mutability of images?
How so?
So like we use annotations to drive security configuration. If someone say pushes in annotations that turns off security,
What's the override? You're actually asking what's the override?
yeah, exactly. Like, is there a way to get a point in time snapshot of all of the referring objects plus the manifest, as opposed to allowing people to add more referring objects that may cause the behavior of the runtime to change?
So so we don't have I don't have any the best answers. What I can say is because these are stored as separate things, you can, at least from the data point of view, know that that annotation was override later. Some of the things that came out of this, for instance, was, well, is there a date stamp on this? Like, how would I order these references back out? And if I copy it from registry to 1 to registry 2, what's the ordering of that copy? Like, what is the date on it? So there is more flushing out that has to be done on it. But I think that there's, like, we've been trying to, Azure, me, I've been trying to solve metadata in a registry for years. Like I've talked to Liz Rice about what she did with, the stuff that she did at Aqua, and there's a bunch of other people that have tried various approaches. This is not a fully thought out thing. This wasn't built for this intention. It was an interesting side effect, like, hey, how can we pull on this thread to solve some of these other problems that we're trying to do? Because remember, this whole thing started as we were solving one problem, and it turns out there was general patterns that, like, wow, this looks like it's solving this other thing that we were trying to accomplish. So to Michael's point, this is one of the reasons we close this one, is because it isn't really solving what we're really focused on right at this moment. But I think there's something interesting here that we can keep on tugging on to solve that additional metadata that for those kind of scenarios.
The other thing about all of this additional metadata, like, it sounds like it's still going to be in tiny numbers. I think you said that at the beginning, but like, what is the performance implication for runtimes having to do lots of like potentially recursive pulls of this metadata?
Don't know yet. I mean, we haven't thought about the recursive. What I'm hoping to do is start introducing some index APIs that say, hey, I can not only get the metadata for the netmonitor image that I know of, what are all the artifacts in a registry that have this name value pair? We've had a hard enough time with Grok and the concept that an artifact type can be filtered on the refers API. So there's definitely a crawl, walk, run of what we want to do. And there's definitely some optimized APIs that can be done around it, but it's like this is there's something interesting here, not ready to go pull on it all the way. I don't know if Michael, you wanted to finish your thought or hand off to Brandon.
I think Brandon should go next.
All right, so thinking through what the image spec says today for images, the config is required, but potentially we could put an empty config in there, and that media type is still important when you're looking at the OCI index definition. So you could just say it's an empty config. It's just a open bracket, close bracket inside the JSON, just up a really tiny blob. Layers, I don't think it's required. Someone can correct me if I'm wrong. And so we could potentially get really close to this minimal example. And so I think the question goes back to some of the image spec maintainers. How important is it to keep that spec fixed for exactly what it's doing versus letting it expand for some of these other use cases and saying, hey, the layers don't have to be ordinal. They can, depending on the media type, they might not be ordinal. And so we can just relax some of these specifications, and yeah, all historical uses of it were ordinal, but maybe in the future they aren't. And so that's kind of like, it's an introduction to a bigger question of, does it make sense? And sorry, I forgot I had my video turned off here. Kind of go into the bigger question of, does it make sense to introduce an entire new media type that we have to manage versus extending the spec? And that's just kind of an open question back to the image spec maintainers of what makes more sense.
I mean, whoever's an image spec maintainer or not, what's the opinion of the group? Because just to add to it, it's not simply adding some properties. Like, the clients would need to know what this is. We're talking about that whole cracking of challenge what Jason talked about this morning. Like, what if you allow something to not be required anymore? What if there is a property there that some should ignore, but some should require? When you could somewhat argue maybe I have to go back and think about it again, the artifact type property may or may not be required, but just adding the subject, and it actually still says subject manifest here as an example. It should say subject, but that's the dating of it. Just adding that isn't helpful unless the registry knows how to do something with it. So the point is that there's no free ride here. Just like registries didn't magically support index, the OCI index, they had to go do work to support that. So, anybody else?
So when you said that registries have to do work to support that, and presumably they'd have to do work to support this change, have you talked to any registry maintainers who have said that this work seems worth doing? Or do you know their general take on it?
Michael, you want to speak to it?
Sorry, what was the question?
Oh, I was just curious if there's been discussions with any registry maintainers as to their opinions on the work required to adjust to a proposal like this, if it were accepted.
Yeah. So the work has been happening in that Auras project artifact spec, the fork of what Steve's showing right now, where I've been participating. So I work on Amazon ECR. Steve's obviously at Microsoft with Azure, and there've been, I think, who's the other? We have Docker Hub that's been participating, and then there's, everyone's obviously welcome. And then I think as we've started to finalize, what we're hoping to do is sort of shop it around to maintainers as well as existing registry implementers. And so this is absolutely part of that in asking for feedback and asking for people to sort of make an assessment of whether this would be something that is implementable. That's not a question that I can answer on behalf of other people, but I think certainly it's something that we are hearing from AWS customers that they want, and something that we would want to implement in ECR.
And I think the key question you mentioned, Rose, is there's that subtlety of want. So, there's been a couple of features we've worked on in registries for a while that, that didn't necessarily hit the value proposition that justified the investment. Any of us running registries have way too much to do and never enough people. And it's a long list of features that are customer demanding features, for security to tenants to reliability, or just capabilities that we can never get to all of them. So the ones that surface to the top are the highest demand. When this started, it wasn't just for the sake of storing, like we definitely had a demand for Helm charts and Singularity and Terraform and others. So we went down that investment, because it was cheaper to do that than to build up another team to run a Terraform server. The thought is security, signing, which has been something we've been trying to do for years, all of us, and Docker Content Trust doesn't cut it with Notary V1. So customers are asking us all the time, we didn't have a viable solution. So now that we had a viable solution, when I go back and ask customers, what do you want me to prioritize? Feature A, B, C, or this? Oh, no, I definitely need signing. So the thing is, the value's got to be there to be worth us doing this work, because there wasn't a free ride to do this in any kind of effective manner. Because if we did it in any other, I don't want to talk about the implementation detail, but the experiences, if we did it in any other way, we were going to wind up with a whole bunch of other support issues and band-aids on top of band-aids to, try to mask noise that was coming out of the system. So the answer is, like, for us, and AWS, obviously they've chosen to go into it. Other registry operators have also been very interested in. They've been busy, so they've been like, nope. let's see how this lands, but yes, we're very interested. And at the end of the day, it's going to vote with their feet, right? The customers are either going to demand it, and the registries will then prioritize this work, or they won't. What we've been trying to do to help it, though, is the combination of doing the work in the CNCF distribution instance, because there are a lot of registries that use that base code base. So we've done a bunch of the work there to flush out and get it started, so that they can go build on it there. But Rose, you start to say something. I saw the yellow bar wrap around you.
Oh no, I think I was just moving to hit the mute button.
Oh, Mike, you got your hand raised still, or is that just remnant? Go.
Yeah, I figured I'd give it a shot. Yeah. It's been a long time since I've been in class. I had to raise my hand. This question is actually for Phil. Phil, I was wondering if you might have any advice. You're one of the few people I know of that have created a second manifest type in this ecosystem. Do you have any advice for the team? You know, what do you think about this project?
Well, first, I'm surprised to hear that I created a manifest type.
Well, index or fat manifest, however you want to call it.
Yeah, I mean, that was like, first of all, I didn't create it personally. I mean, Derek McGowan, Steve O. It was work that was ongoing at Docker at the time. Actually, there's two names that no longer part of any container org that were even before those guys working on that. So, yeah, I'm not trying to dismiss that, there might be value from thinking about it that way, but it was so early in the ecosystem that they already made a huge shift, like the V1, Docker V1 was shifting to V2. Like it came in an era where people were going to have to migrate a lot of content anyway. And so I don't think it was really as tricky a inflection point that we have now, where there's billions of images and tons of managed cloud registries. Those things just didn't exist in those very, very early days. So I think, but since you gave me the floor, the one comment I'll make at this point is I think something that's holding up this discussion is I feel like not to call you out, Steve, but I think you did a great job giving us the experience that's the actual requirement. Customers could care less whether it's artifact this or as that. Like, we have to, I think a lot of people are trying to ask the question, well, okay, yeah, a bunch of people said no a long time ago. Like, today, people are asking, can we give those experiences without going to this exact implementation? And I think you're saying no, and a lot of other people are saying, can we talk about it? And I think that's where we're stuck. And then I think it would be good to complete the proposal that was started, create a working group, and actually hash out those two paths and come up with an actual decision point of, here's the things we can do, and here's proposal one. You've already fleshed out, the artifact manifest. I think everyone's read and commented on, on the issues and pull requests for months. So I don't know, that as I sit here, that's where I feel like, just to kind of break through the discussion, like, people are asking, can we do it this way? And I think we're not getting to the point where everyone's on board to say, yeah, let's work together and figure that out, and stop saying it has to be this way or this way, because that's I think you just died here.
I was gonna say, we can't hear whoever's talking in the background.
Yeah,
Is it-
Steve.
How about, okay, we think this battery died, which, yeah, looks like it. I think I wouldn't say it has to be done any one way. The thing that you've been seeing is, like, if you look back at all these PRs, like, this has been going on for a couple of years, and I'm not trying to make a point of time, but if you bounce around on them, I don't want to call it whack-a-mole or whatever, but we have tried so many different approaches. And then we like, no, you can't do that. Okay, what about this? Well, you can't do that. You should go back to that. Well, we were told we can't do that. Well, what about this? Well, we've learned something new that maybe we can do this. So it's not, and then if I try to explain the feedback I got from 4 different people that are now busy on something else and can't explain why that was a reason, I write a long doc and then I get, that's a wall of text, don't bother me. So I'm up for all of this.
Yeah.
Like, I'm not doing this because I love getting beat up and wasting my time on all this stuff.
No.
I really believe that this is a thing, and I don't want it to be outside of OCI.
Yeah.
But we had to find a
Well-
way to do it where 2 fierce competitors can collaborate without having legal and other problems going. So I'm doing this because I want to find that collaboration, but it has to be an engagement that has the time commitment and the willingness to collaborate and move forward, not no, go over there, no, go over here. But like, how do we make this work going forward, and how do we break through the problems that Jason outlined earlier?
Yeah, and that's yeah. I think the problem with talking about it historically is, like, you showed up to the OCI at a time when everyone had disappeared.
Mhm.
Vincent was gone for a good while. I kind of lost, had focus elsewhere for a while. So I guess what I'm struggling with talking about history is, like, right now there's a bunch of active people who seem to really care about this topic,
Love
which
it.
is great. And I think we're going to have to find a way to say, I'm sorry that things didn't progress the last 2 years. I wish they had. I wish the right people were involved. But the problem is, like, we can't fix that right now.
I'm not trying to rehash the back,
Yeah.
but this is even recently. I mean, like, within the last weeks, we get
So-
feedback
so
and bounced
here-
around. It's
yeah.
not
So here's
constructive.
here's my advice for that. Ask the TOB to vote on the working group. I told you to do that a month ago. And then time box it. We're going to decide by this date. We're going to have all the discussions we want to have, and then come up with the proposals. That way, there's not this, never-ending, like. That's the only way you can take a bunch of different opinions and come to an agreement, is to say, if you're too busy, you can't come to the meeting, I'm sorry, then, we have to decide here because companies are making decisions and implementations have to happen. So I think that's the problem, is, like, it's not that a lot of people just are wanting to get in the way. It's that there's not a set of very discrete steps that have been laid out. Here's the working group, here's the timeline, here's the goal. Because once you have that, then that's the club is the wrong word, but that's the thing you use to say, if you weren't here, here's the decision we made, and that, that's life. But if you don't have that plan, then it just seems like we're in this never-ending churn of discussion and no answers, and, well, this person has this thought. So that's my opinion. That's my advice.
We're a couple of minutes over, but we're in a break. Any other questions?
Oh, wow. Sorry.
I'm kind of having this discussion on a thread in the chat, and it might be worth bringing up here.
Yeah.
The way that we run our registry, and I know other people run their registries like this, is their security posture is anyone can upload, downloading is somewhat limited, and no one can delete. And that gives you the ability to say that, like, you don't really have to worry about, because everything's immutable, you don't really have to worry about access control too much. and you can verify the authenticity of the image at runtime based on that immutable manifest hash. Now we have all these things that can affect the runtime characteristics. And for example, if someone uploads a security scan saying that there's like a Sev1 vulnerability that makes an image impossible to run.
Doesn't make it. It gives you data to decide whether you want the image to not run.
If the runtime sees an annotation that says that this image has a vulnerability, and the policy is don't run vulnerable
Policy,
images.
but that's the point.
But
Anyway,
like,
but yeah.
So like how, like this kind of changes a large aspect of the security posture I think that people have on registries. Because it means that you have to be able to delete data or have tighter controls of who can push stuff to your registry.
I'm struggling with it because there's a couple of things you said about, nothing ever gets deleted. Like, I don't want to ever say anybody has ever. We definitely have problems where we don't have enough tool, even though we support delete and support, fairly rich queries on how to do delete, it is still not enough. There is not enough metadata in the system for people to understand how do they separate their production deployed images versus the crap they built they're never going to use. So I don't want to pivot too much on that one, but like, I guess where were you going with it? What is the thing you were?
So like,
because I thought you were going that we shouldn't have to worry about lifecycle management because you should never delete anything anyway.
I guess the biggest thing is like, if anyone can, so like with our current posture, where anyone, once they have access to the registry in general, can push anything to any repository, if they're able to push things that will affect an existing manifest, it changes changes our requirements around our security posture. We have to be more controlling of who can push what to what repository.
So your premise is that because anybody can push to any repo, I could push something that would keep it from being deployed.
Right.
And I guess I'm a little surprised you're saying anybody can push anything to any repo.
Well, it's fine. Like, write-only storage is great.
And content addressable, I think the concern here is when we add the reference types, and that those reference types give you that ability to modify other artifacts that are there, where before you couldn't touch someone else's thing that they pushed up.
Sargon, I've got a question for you.
Yeah, we hear you.
In your model, can anyone push tags too, or is it just pushing content?
Anyone can push tags, and we tell people not to use tags in production.
So you have a separate data store that tells you which digest to actually use in production, and that data store is not open authentication.
That data store is like super tightly controlled, and there's like an entire team and toolkit to manage that.
So it sounds to me like you might want to do the same thing for references.
But how do
you have access control over, the ability to actually associate different things together? Since that's your mechanism of discovery, or that's your mechanism of controlling what content matters.
But if it's all in the existing registry, we would have to add controls around the existing registry. And sometimes that's easy to do, but like, for example, if we wanted to use like Artifactory, I have no idea how we would do that with Artifactory.
But let me also tease us a little bit, because you're worried about if I can push new things, but that assumes you can pull by the reference type. So you have to go implement the referrers API to even get that information out. You could, whatever the ecosystem is that you're trying to enable, that you could also put filtering on it or not allow the referrers API. I mean, the whole authentication models that we've had in registries has always been, I don't want to say vague, it's been left to the implementation for lots of different reasons. We've seen, like, we definitely get questions on, I only want to push to repo 1, not repo 2. I want to be able to pull from repo 3, but I can push to repo 1, 5, and 6. We've seen some customers and some products, I think CodeFresh either does or did, do tag level permissions. So I hear what you're saying. I agree with you. It's an interesting problem. I guess I would look at it from a different way to do permission models, because what Sam was poking at is, if I could push anything, I can push bad image to tag deploy now, whatever the tag is you used. But what you're saying is you don't deploy by tags, you deploy by digest. And so
I guess it would be valuable if there was consideration for at least at runtime to be able to capture the set of references and the manifest as some kind of immutable hash.
So they are all immutable digests. So